Hello and good morning, everyone, and welcome to BSides Munich as a service in 2020. I hope every one of you can hear me right now. Um, I'm Maximilian. I'm from BSides. I'm actually doing the complete sending and moderation today. Don't worry, it's actually not very much. Um, Honestly, we will start with the opening hello from now, so saying hi and yeah, sticking to sticking to my notices right now because it's actually 11 o'clock, or actually going right now in the direction of 11 o'clock. As you can imagine, as an IT specialist, as an IT nerd, it's actually still not my time completely. Everything before 12 somehow, but that's fine. So, I hope every one of you is healthy and fine right now, and looking forward to the speakers doing the presentations today. I'm actually very happy that it worked out, and I have to say also a very big thanks to a lot of people here. Um, First of all, my team here working with especially Chen and Chris doing the setup, doing the tests. Also yesterday doing weekly meetings. That was hard, and it was actually also very short. So I'm happy that it worked somehow out. Also thanks to and the people making this possible inside the community. Also, big thanks to the volunteers working with us today. If anyone wants, please take a look at the website of BSides 2020 and just join there our wonderful Slack chat. We will have also our own Slack rooms where you can just jump in and ask the people what you want to know about the topics we are going to show you today. Also, thanks to the sponsors. Yes, we have sponsors this year too. And jump to the agenda right now. So here you see our agenda today. So you have also a short intro with me until officially 11 o'clock. I will not take the whole time, I hope. Then we have as our first point today the pen testing, louds and boxes in the wild from 11 to 11:45. We have also game hacking for noobs from 11:45 to 12:30. We have hacking a smart coffee machine. That's actually the one I hope to see because I need a new coffee machine, and a hackable coffee machine would be great. That's going from 12:30 to 30:15. We have OWASP API Security Top 10 from Frank Eli with how APIs are hacked from 30:15 to 40 o'clock. And then how to shield an IoT product from OWASP Top 10, IoT Top 10 from Pablo Andres. It's actually a very current topic from my point of view. We are getting more and more IoT stuff here. The supply chain attacks, the rise of the third-party pubers from Marilla Shapira, Kubernetes security, a development's nightmare, and the art of bypassing endpoint protections for red team engagements. That's actually lasting until 17 o'clock or actually 5 o'clock p.m., depending on the view how you would say it. Also, a big thanks to the sponsors you see on this slide. The upsides on the BSides in Stuttgart, but also for Airbus, Sios, Siemens, Fujitsu, Google, Huawei, Mugway, ITSEC, Kemet Müller, Maltigo, Einseit, Zaris, and Schutzwerk. They are very helpful. They would have been more helpful if we would have done this year in physical form. Anyway, we wanted to say thank you here, and we will start with the first talks in about 5 minutes. Until then, you will have now a few seconds to take a look at the daily schedule again. See you then. One point, actually, I forgot about to say. We have, as already mentioned, Slack channel. If you have questions, please ask them. We have also for each talk our own room. If possible, also the speakers will show up because we have the pre-recorded sessions. If you want to take a look at these sessions later, we will also ask the speakers if they are okay that we actually make a playlist where you can find each video again from the speakers themselves. Maybe also for a short time schedule, because there are also speakers doing this in their daily business, selling this in their daily business. So it is actually for us a honor for each minute hosting that. I also wanted to say hi to the chat. I'm actually seeing it on my other monitor, as you can imagine. There are also 43 people right now joining and already have joined. I'm very happy to see that. It's actually very active for such a short time. And we have also a Twitter. If you don't know, please follow the Twitter. It's actually BSides Munich 2020. So not BSides 2020. It's only BSides MOOC. We have regular updates, and we hope also for a virtual, not only for virtual, also for a physical conference next year. We hope to see you there too. We hope that it will work also to the current situation. And then we can start in a few minutes with the pen testing cloud sandboxes in the wild.
To our conference talk, Pen Testing Cloud Sandboxes in the Wild for BSides Munich 2020. in August. We will present our content, and before we start, we'll introduce ourselves. First of all, who we are. Matthias, introduce yourself, please.
Yes, hello everyone. My name is Matthias. I work as a platform security engineer at Salesforce, taking care of our platform as a service offerings. Very happy that we can do this talk together. We're actually sitting next to each other, even though we live quite a bit away from each other. So yeah, very excited. Dealing with cloud containers almost full time for the last 4 years now. Still love the topic and I'm very excited for the talk.
Yeah, thanks, Matthias. My name is Jan. I'm a kind of IT security specialist, and I love to play around with containers and orchestration solutions. And nowadays, I'm working as a freelancer. Did worked in this area and in security area the last few years as a consultant, as a penetration tester, and whatnot. Yeah, okay. So, enough to us. Let's have a start with the content. We will start with a short recap. Last year, you heard from Andreas Krebs on BSides Munich 2019, a talk about containers. He introduced you to what's about containers, how do they work, the history, what's Docker, what's the Docker engine, and how are these container images composed, how does it build up, and so on. In general, we have a container, and you can see it on the right-hand side. A container is building up on a legitimate host system. How does it exactly work? We will have an idea.
Also, 1 second, if you're not super familiar with containers yet, we would recommend that you look at this talk and watch this talk from last year because it's a really good container introduction. So if you're not familiar with the container basics, we will not cover those. So before watching this, go ahead and watch the talk from last year.
Thanks, Matthias, for the hint on this situation. Just to get a short recap, what we are focusing on. So first of all, Linux containers are just a group of processes, and they are bound together based on Linux kernel features. What exactly kind of kernel features we have in background? Linux namespaces that are used for isolation, like user namespaces, networking, file system, whatnot. And what else kernel features are used? In special case of Docker, they use C groups to limit the resource of the system, and even the capabilities are reduced. And we even have introduced some seccomp filters. So you have not all access to the kernel. They are limited by dropped capabilities and filtering and so on. What kind of container environments do we have? Actually, we have the runC system containerization tool. LXC is the old one. Maybe the old guys from the hood know. Nowadays we have like systemd or Docker or even Firecracker to name some new one. Actually, you can have multiple containers running on the same host. Well, it's just a group of processes that stick together and bound together. And normally, in terms of containers, you never have a virtual machine, but in some special edge cases, you have some lightweight virtual machines like Kato containers or Firecracker, where we have a microkernel started as virtual machines. But we will come to this in a later situation.
What I always find super interesting is that the term container is absolutely not defined. It's very often the case with any like industry-driven, I don't want to say standard because that implies that there is some definition or standardization, but it's not the case for containers. So with all those container runtime environments like lightweight VMs or down here on the left runC, LXC, Docker and so on, so you basically need to just look at the code, what they are doing, and that's what a container is. There is some degree of standardization coming in with OCI, the Open Container Initiative. So that's pretty much the most standardization that we have, but it's still rather new and has not arrived everywhere yet.
So, okay, get back to the talk, what we will cover this time. We will discuss at first some container breakout techniques that are possible and what you can perform on normal containers, and the general attack surface of containers. That's maybe an interesting topic, but to be honest, it's almost kind of a misconfiguration issue. And when you talk about your container security situation, it's normally not all of it. The relevant risks are coming with the control plane, management of the control plane, the API, supporting services that are used to build up containers, or even your supply chain. These are the real hard and tough things to cover. But before you can solve these issues, you must get an idea for the basic stuff like container security. In terms of attack vectors on the host file system, from the container perspective, we can share only just directories with the container or even the whole root directory of the host. But if you start a container with an insecure configuration, you may have shared the whole root host directory. And if you have access to the directory from a container, you're still root on the host file system. To escalate from a container to the underlying host, you can use in this situation, just normal Linux privilege escalation techniques. For example, you create a new user and connect by SSH, by deploy a new key, or even create a new cron job and wait for a reverse shell connection, something like this. There's something what you can perform in this situation. Another big thing everybody's talking about, and you may have here, is just the attack vector by privileged containers. If you start researching and looking for some details about privileged container and container security, there's always the hint, never start your container privileged. You say, well, what does it exactly mean? A privileged container gives you direct access to the Linux kernel from the underlying host and to the hardware of the host system. What do you actually have? The security measurements that were introduced by Docker to have somehow a separation between the container and the host kernel is by only a limited access for the sys file system. You know, this is a file system for the Linux kernel where you can access it directly. And normally the capabilities are dropped, and in terms of a privileged container, you have access to serious capabilities like sysadmin or sysmodule for loading kernel modules or something like this, or even access to the host devices. What could probably go wrong? Yeah, you know, you can, if you have access to the devices, you can just go and mount the host, the volumes like the hard drive into the container and modify it. So it's like similar to the previous attack case. Or even just from one of the last blog posts that was published was like access to the proc keys, where you have the kernel key ring access to and read out the details out of the key ring. But in this case, I would recommend you to dig into the blog post. It's amazing. What kind of attack vectors do we else have? Actually, we have in some cases that you start your container with a mounted Docker socket. The Docker socket, why do you actually need the Docker socket in the container? The Docker socket is the control plane to control your containers on the local system. And if the control plane is mounted into a container, for sure what you can do is just use the control plane and start a new container. And these containers can be started in any flavor you like. For example, you make a superpub container, which is privileged. You have access to the host network. You can directly interact with other processors by IPC and even modify the host namespace. And if you the last step to get out of the box is switching the mount namespace, which you can use as the system command nsenter, and then you are with nsenter -t1 and -m, then you are in the mount namespace of the host of the init process, and then you actually are owning the system. That's also an attack vector. So, since we are talking about the cloud, the previous attack vectors were more likely to be for local systems, if you have a local Docker container that started. But if we are in a cloud environment, what actually is the dangerous part? Where's the cloud interfaces? The most interesting one, and if you're looking into bug bounty, for example, there's always an edge case and everybody's talking about server-side request forgery. Though you have access to the metadata API, it's a control plane of the cloud. And just having a container start and stop in is just one point. But if you decide to go into the cloud with your containers, you normally leverage features from the cloud. What exactly does it mean? You have service accounts for the metadata API, just access tokens for this metadata API. And from there, you can control the workloads. You may have access to the storage that you have configured, like an S3 storage or something like this. Or in worst case, you can even go and can take over the cloud account. Depends on the configuration of the access tokens. We have compared common cloud platform provider that are out there. To name a few, to name them, we have AWS from Amazon, Azure from Microsoft, just local Docker. A new cat from the blog is the Fly.io, and even GCP and Heroku as container providers. To get an idea from the comparison, in the default case, you have in case of AWS ECS, the metadata API. In this part, we have a remark that you have a custom cluster that has to be started exclusively for us. In AWS Fargate, in comparison, you have a shared host. So you can see it based on the seccomp filter, for example, that there's a separation. Furthermore, in case of Fly.io, we have what I told you beforehand, a micro light VM virtual machines like firecrackers, so you don't have actually not access to the Linux kernel, the underlying kernel. There is an abstraction layer for the kernel by the firecracker. In case of Google Cloud Run, we have the gvisor, or in Heroku, they use under the hood LXC. And so from this derived, we have different measurements. A detailed comparison is on the GitHub site that's linked below the image. And there you can find all the different capabilities and seccomp filters that are introduced. Okay, the summary of the attack vectors. Matthias.
So Jan was giving us an overview of the different attack vectors. So basically I would summarize them into mounts from the host system, which opens up possibilities for all the different traditional Linux local attack vectors. We can have privileges assigned to a container. It can be either fully privileged, you can have some capabilities, some system calls might not be filtered, or access to certain unnamespaced entities, components might not be available, like for devices. Then you may have sockets mounted. The most prominent example is the Docker socket, and you have control plane access. By that we mean, for example, access to the cloud metadata API, but it can also be other control planes, as we will see in a moment. So, if you want to perform an attack surface analysis or pen test cloud sandboxes, container environments in the wild, as the title of our talk suggests, there are actually two amazing tools already out there. There is Bob with a silent T by Chris Leroy. Link is here on the slide. And then there's Am I Contained by Jess Frazell. Both of those cover slightly different aspects of those breakout vectors, and we will go through them right now. Also, I have a backlog of things that I want to add to the tools. Jan already had some pull requests merged into them, so we're really big fans of those tools. So, if you want to automatically analyze those attack vectors, first we will have a look at Bob. one of Chris's hobbies is looking for Linux sockets and find fun things that you can do with them. So there's a lot of options available for that. So there's also an autopone option, which is basically it moves your own container into the host namespace with like everything namespaced in the host. So basically your current process is running as a regular Linux host process now. This is abusing like an exposed Docker socket, and the autopone option basically just does what you usually want to do, get a privileged environment. You can, however, also look for domain sockets that are available. As I said, the Docker socket is just the most prominent example, but there might also be other sockets available. We've seen cloud environments where the hosting provider exposes services into the container, for example, logging services or also control plane services via Linux domain sockets. And since this is usually local, they often don't worry about authentication or something like that. So we also have an option to like hunt for any type of sockets that might be available in the container, and chances are that those are quite interesting actually. Then there's two control plane options in Bob. So it's extracting mounted Kubernetes secrets if there are any available, and it is also parsing for metadata access to cloud services. This is the contribution that Jan actually made to the tool.
Yeah, right.
So this is what Bob does. There's also some other like fancy features in there. For example, there's like a CI pipeline use if you have a build environment that needs this type of analysis. There's a CI mode involved. You can also like upload the scanning results to an S3 bucket and such. And yeah. Then we have MI contained. MI contained gives you an enumeration of the other privileges that your container might have. It is also checking for the Docker socket, as we see at the very bottom, but this is only like the standard location of the Docker socket. If you want to perform like a more comprehensive search for any Docker sockets that are available, you want to use Bob. What MI contained gives you is a good analysis of the enabled privilege separation features going from top to bottom, basically whether namespaces are available, and it's here checking for the PID namespace and the user namespace. So we see user namespaces are not being used here. This container is also not running with an AppArmor profile assigned. We have certain capabilities that are limited, and we have certain system calls that are blocked. So the interesting part is, if you would want to do this manually, you could via /proc/pid/status actually identify whether you have seccomp filtering enabled for your process. However, it only tells you is it enabled or is it not enabled. If you want to know which system calls are blocked, you just actually need to try and perform all system calls and look for the return code that you are getting. This is actually quite interesting, since on the Heroku platform we often got bug bounty submissions that said, oh, you're not doing system call filtering, but certain tools are only looking for certain error codes, and we return a non-custom error code for our filter system calls. So be careful when you perform this analysis there. So these are the tools that are available for automatically assessing your container environment, and I think this is also what Jan used for creating the overview of those environments. So also, what can you do about that? If you want to ensure that your containers are properly hardened from the runtime perspective, we will come back to that, but as we said, this is only one aspect, and I often refer to this as container runtime security. So if you want to harden your environment and you want to mitigate all those potential problems, what you have to do depends heavily on your runtime. If you use a public platform as a service runtime environment, there's usually not that much that you can do. They basically won't allow you insecure configurations with regard to breakout techniques. I mean, that's in their best interest to maintain isolation. Otherwise, they could not offer a multi-tenant platform. So if you want to definitely host your own environment, which may be required by some security policy or some consideration or whatever, you have to harden your own runtime, obviously. So there's basically two options that I see. You can build your own abstraction layer for deploying workloads. So you basically offer like a small web service where you can submit workloads to, and then you basically build your own runtime container yourself with the own runtime configurations that you choose, and the abstraction layer that you have basically just allows for submitting a Docker image, but how this Docker image is started and how the runtime is configured is completely up to you as the infrastructure provider. If that is not an option for you for some reason, you can still basically analyze the deployment artifacts that are being submitted to you. And there are already several tools out there. When it comes to Dockerfile, there are actually 2 linters out there that gives you very good results when it comes to security or best practices in general, but also security best practices for Docker files. For example, don't run as root, don't use add don't use add at all if you can avoid it. So there's two options available for Docker files. For Docker Compose files, we're not aware of any tools that do that. However, I also don't think Docker Compose is super relevant anymore at the moment. Personally, I like Docker Swarm a lot, but everybody else has jumped on the Kubernetes bandwagon. So for Kubernetes, there's actually many options available how you can harden your runtime environment. This is only like a selection of tools that I like the best. So the top one is MKit, the Managed Kubernetes Inspection Toolkit, that does not only analyze your running containers, but also your cluster configuration. There is Styra, which is a paid service by the Open Policy Agent founders, I think, or at least some early developers, that basically now offer you managed Open Policy Agent configurations for your Kubernetes cluster for all types of things. Something very similar is K-Rail. It's a very similar concept that also like hardens your cluster and also continuously monitors it. It's also a very good tool, and then like a more of a like audit-based tool is KubeScore. However, when it comes to hardening your runtime environment, it's actually also not that hard to harden your Kubernetes cluster yourself. Kubernetes clusters have something that is called admission controllers, and you can basically integrate pod security policies and OPA. They have a big overlap in what they can do, but some things can only be done with OPA, for example. So you determine the hardening that you want to perform, and then there's actually good guidance available how you want to design your pod security policies and how you can actually tie that into an admission controller. So admission controller is a feature of Kubernetes that, as the name says, controls what is getting admitted to the cluster. So any deployment is pushed through a chain of admission controller hooks. So you can also write your own admission controller and just hook into that chain and then basically give a yay or nay upon deployment. However, all those admission controller or any webhook controller in Kubernetes clusters are very so basically they are blocking. If you want to deploy anything and one of the controllers that are being configured fails, nothing works anymore. You can't configure your cluster or can't make any changes. The running workloads, they just work fine, but any changes that you want to do, they need to go through the admission controller chain. So if one of those fails in there, anything's going wrong, you have to troubleshoot and debug your cluster. So they are a little bit of a double-edged sword. They are cool things that you can do with them, but at the same time, they are also mission critical because they can be blocking changes to your cluster. So, summing this stuff up, containers are an amazing thing from an engineering perspective. We're both like huge fans, and I think we use like Docker containers for lots of daily tasks.
Almost everything.
Yeah, right. And you can definitely operate them securely. As I said, I'm working for like a big platform as a service provider that is whose isolation is mainly based on containers, and we did not have to release any press release about failed multi-tenancy issues yet. So you can definitely harden your container properly and also enforce proper tenant isolation with them. You don't want to misconfigure anything. Actually, also many containers come in quite a yeah, many container runtimes come in quite a secure default configuration. I have to admit Kubernetes had some ugly outliers in the past, where basically if you wanted to run a pod as a non-root user, you could configure that, but Kubernetes was not doing that. I think seccomp filters by default are also just finally coming to Kubernetes. So
You can import them by pod security policies.
you can do that, but the default deployment does not leverage those. So with Kubernetes, you definitely want to pay some attention to your hardening, but if you have a default Docker runtime, the state is actually not too bad. Yeah, and then it completely depends. Obviously, I'm a big fan of platform as a service providers that offer you container services, but what you select in the end might heavily depend on your company policy or which golf court your company execs are going to. So have a look at your cloud platform provider. You have now some tools to analyze what they are offering you from the security perspective, and this should enable you to properly harden your own environment wherever it is running. Some further tasks that we have on our mind, some tooling that we want to do, so for example, a cloud metadata scraper for all the big cloud platform that basically just dumps all the metadata content, is something that's not available from my perspective yet. The one project that I want to do since a long while is a container privilege footprinting, where you basically run a container and monitor which system calls and capabilities and such it is using, so you can actually minimize the available privileges to it. We also want to extend Bob to scan for binaries with assigned privileges. So those privileges, the capabilities that we talked about earlier, they can also be assigned to binaries, not only to users, but also to binaries. So this is a very interesting thing.
And a good way to backdoor a system.
Absolutely, yeah. And then personally, I also want to extend the MI contained documentation. So you can actually also read about what MI contained does, what the impact is, and make it a little bit of like container privilege knowledge base. You can always read the code, but we all know that can also be tedious at times. And now, thanks for your attention, and we're more than happy to take your questions in any form.
Yeah, thanks for your audience.
While you gather your questions, here are some references that we have in here, and also shout out again to Chris and Jess for their amazing work with Bob and MI Contained.
To our conference talk, Pen Testing Cloud Sandboxes in the Wild, for BSides Munich 2020 in August. We will present our content. And before we start, we'll introduce ourselves. First of all, who we are. Matthias, introduce yourself, please.
Yes, hello everyone. My name is Matthias. I work as a platform security engineer at Salesforce, taking care of
So, this was it for our first talk. As you see, I have recently gone back from shower. Yeah, oops. Besides of that, I don't worry, there will maybe some incy tiny little problems here and there because I'm also doing things maybe in parallel from time to time. So it took it can be that there are at some points little problems, but we're working on it, and I think that we will do just fine today. Okay. Besides of that, thanks for the first talk here. So thanks also for and Harry, who's also doing the FHQ in his room right now. If you have still questions, the FHQ will open until 11:45. You can also ask after that questions, but if they are not answered, just write them to our mail. We have also the link in the video description right now. So under 2020 BSides.munich.org, you find also a contact email. If there are any questions rising, just ask there or ask us directly in the chat. Just for your information, my name in the chat is Maximilian Tech Hazelberger. So you can also write me if you have any questions about the stream at all. We have also three other administrators, or actually, no, four other administrators. Jen, Sneer, also Blurp. We have my Damien and Christoph. So actually had to look up the nicknames right now. Okay. Besides of that, thanks to Matthias Luft and Jan Harry. Pen-testing loud sandboxes in the world. Our first talk for today. We have still 7 to go. I'm looking forward for the next one, which is Rush Be Pliant Game Hacking for Noobs. See you then in a few seconds. And I have right too much links here to click. Hello, and here I am again, back again yeah, that I wouldn't say. I'm actually still sleepy somehow. I don't know why. But yeah, anyway, we can go on with our BSides program now. The next point, yeah, video. Haha. So the next point will be Rush Be Blind Game Hacking for Noobs from Philip Schmid. I'm actually looking forward to that as well. I wish you, yeah, happy looking or some fun for looking. Also, again, thanks to our sponsors. And if you haven't joined recently, we have our Slack, and the Slack's ongoing. So just join the Slack. You can ask the questions. So do it.
Yo yo and what's up? Welcome to my talk on game hacking. I do computer stuff and I also have a blog, and if you want to know more on game hacking and the stuff I'm going to present today, you can also read my blog post, which you can find on this link. That's me, 12 years old, wondering how wall hacks and aimbots and all these cool hacks for Counter-Strike work. And now 1 year later, I've decided to create some hacks myself and present my results. Cheating is actually quite popular in professional Counter-Strike Go gaming, as you can see right here. This guy was caught cheating on a tournament and kicked out immediately. And of course, it's also profitable to create cheats and sell them, and also to use them, because if you win at the tournament, you can get lots of money. Also, I think those techniques I'm going to use for game hacking are quite interesting, because you can transfer them to stuff like malware creating, malware writing, and antivirus evasion. There are a few tools you're going to need. For example, I'm using Visual Studio. I'm creating all my hacks in C++. And you also need a debugger for the games themselves. I use x64 debug. And you also need a reverse engineering tool of choice, for example, Radar, Cutter, Gitra, IDA, whatever you need. And a really handy tool is Cheat Engine. It allows you to scan game memory for known values, and you can basically find all those memory structs and objects using a simple scan of Cheat Engine. There are a few types of game hacks that you can create, one of them being internal, which means you're injecting custom code into a game's process and run inside of that memory segment. And also there's the external hack, which reads and writes memory of another process externally. You can also use something like Frida to instrument your games, but I'm not going to go into that today. The first hack I've created is for a game called Jedi Knight Jedi Academy. It's based on the IT Tech 3 engine. People also call it the Quake 3 engine. When you're creating hacks, you need to be aware which game engine is in use. You're going to use a different approach for IT Tech 3 engine based games compared to something like Counter-Strike Go or other games. You need to have a basic understanding of the game architecture and the rough program flow. For example, for the ID Tech 3 engine based game Star Wars, there's the main executable. It's called yamp.exe, and there's a server virtual machine and some client virtual machines. And those virtual machines, they use bytecode to be portable across different devices. That's part of the game engine itself. And the important thing is that they are implemented in own DLLs. And the most important one for game hacking for this engine is the cgame virtual machine. The virtual machines and the main executable, they can call themselves. For example, it's possible that the main executable performs a call inside of the DLL, and of course the DLL can also perform callbacks to the main executable. So for example, if the main executable wants a new frame of the game to be rendered, it calls a function of the cgame virtual machine and delegates the task to this virtual machine. The cgame QVM is implemented in the cgame x86 DLL file, and it has exactly 2 exports which you can list using Radar 2. The DLL entry export and the VM main exports are helpful when creating hacks. So for example, the VM main export is being called by the main executable to perform calls inside of this DLL. And the prototype of it is like this. You specify a command in the form of an integer, and you can pass 12 additional integers as parameters, which is like a generic way to perform calls into this QVM. And the handy thing about this is that this function gets called for things like a new game is being loaded or a new frame is being drawn on the screen, which you can now intercept when you're creating hooks. So for example, if you're creating an aimbot, you want it to perform calculations each frame and check whether the view has to be adjusted to automatically aim at an enemy's head or something like that. And then there's the DLL entry export. It allows the cgame QVM to perform callbacks into the main process. So for example, if a new player is being added to the screen, or if a player moves on the screen, or new game data is being received from the server, then this QVM will perform callbacks into the main executable. This is the prototype for DLL entry, and one important thing is that it receives a function pointer from the main executable that points back to a function inside of the main executable. So you can use this one to perform callbacks. But more importantly, you get notified in case an entity is added to the screen or it moves, as I already said. So you can manipulate this program flow in order to display an entity on top of walls, which is the main goal of a wall hack. So let's see what happens as soon as the main executable wants to call DLL entry. It loads this DLL inside of its process space, and it calls the Windows API function getProcAddress with the argument DLL entry. This call returns the address of the DLL entry function inside of this DLL, which the main executable can now use to actually perform the call. So the plan is to create a hook in getProcAddress for the main executable and return our own function in case the main executable wants to perform a call for DLL entry. The actual code of the hack has to be injected into the game process. And for that, you can use an easy method like DLL injection, which causes a DLL to be loaded inside of the target process and to be called. For this, you need a loader and a DLL itself. I've created my own loader, which basically follows a standard technique called load library. You open the game's process using its PID and you get a handle to it. You're getting the address of the load library function inside of the kernel 32 DLL and store it in this value. Next, you're allocating memory inside of the target process. You're allocating max path bytes and you make it writable. Next, you're writing to this process memory and you're writing the path to your DLL into it. And lastly, a call to create remote thread is done, which causes the game to call the load library function on the path that's passed to it. So it loads the DLL and it starts at the DLL entry point, and you can verify that it's working by spawning a message box or something like that. Of course, this technique is not very stealthy, so to bypass any anti-cheats, you may do some additional work. For the hooks themselves, you can use a library like mhook, or you can implement this functionality yourself. I've used the mhook library for my project, and it has an API that you can pass the original function address and the function that has to be called instead, and that's it. So now, with the call to get proc address being hooked, you can check whether DLL entry is being requested, and you can replace the returned address with your own hook DLL entry function. And for all other cases, you just call the original get proc address and let it handle the rest. So now, with the hook being set up, I wanted to create a wall hack. And I've integrated the official SDK for this game to have all flags and values available that I'm going to use now. And I proceeded to intercept the function that adds entities to the screen. I've created my own function called syscallHook, which gets called instead of the original syscall handling function. And I've created one case where I'm going to execute my own code. And that's the case as soon as the command equals this value. And this tells the game engine that the entity that's in arc0 is going to be added to the screen. And I'm just hijacking this value, and I'm adding another engine flag to it. And this flag tells the game to ignore any def information for an entity, which causes it to be rendered on top of the screen for all walls or items or other things. This is what it looks like in action. You can see those enemies through walls, and I've also added some custom shaders for enemies, so you can actually see who's an enemy and who's a friend. The other hack I've created is an aimbot for Counter-Strike Go and for the Linux version of it. You need some tooling for this to make all this game hacking stuff work. You need cheat engine, and you need access to the proc maps file of this game, so you can see where shared objects are being loaded into. The general plan to create an aimbot is to find your own player inside of the memory and get those coordinates from it, so you can actually see where you are on the map. You need to do the same for all enemies, so you need to get those coordinates as well. Then I proceeded to calculate who's the nearest enemy, and then I adjusted the aim to this exact enemy. So now it's required to find the own player inside of the memory of the game. And I knew that there's a shared object, it's called client panorama client, and some functionality is actually directly handled by this shared object instead of the main executable of CSGO. So then in Cheat Engine I've selected this shared object and I've performed some memory scans inside of it. I've searched for known values such as the health of my player, and then I've decreased the player's health by jumping off a ledge or typing in some commands in the console. And then I've performed a new search, and I did it all over again, and then you eventually end up with a list of maybe a few addresses that contain the actual health of your player. Now the problem is that as soon as you restart your game, most of those addresses will become invalid, since the game will be mapped to a new location in memory and all those shared objects as well. What I did was I added all addresses that contain the health to the address list of Cheat Engine, and I've restarted the game a few times, and some pointers, actually it was only one, remained valid across multiple game restarts. That's what's called a static pointer, that you're going to rely on to always find your player structure in memory. If you don't have a static pointer, it will be really difficult for an external hack to do stuff reliably. I did the same for enemies as well. I've created a game with bots and I've typed in some commands so that they are frozen. And then I pushed them up hills and pushed them down, and I performed some scans in Cheat Engine to see increasing and decreasing values. You need to do that all over again, and eventually you'll end up with values that seem to be coordinates, and you can verify it by displaying them on the screen and pushing the enemy, and you can then watch the memory changes live and verify that you found the real address of an enemy in memory. For CSGO, there's a structure in memory that contains all enemies in an array, and the object I found on this GIF that I'm showing here is inside of this array, so I can just loop over this array and get all enemy structures in memory, and with that of course all coordinates of them. And now you can calculate the 3D distance from you to the nearest enemy. So you take all enemies, perform this calculation, and you check the minimum of this calculation, and then you have the nearest enemy. Now the last remaining thing is to actually calculate the angle you need to look at to automatically aim at an enemy's head. The first thing that's calculated is a delta, which means you're taking your x, y, and z coordinates and you subtract them from the ones of your enemy, which makes you, in this imaginary triangle, the new origin. So next, you know this value and this value. So you know two sides of this triangle and there's one side missing. The next calculation does exactly that. It calculates the remaining side of this triangle. And now it's possible to calculate the two angles you need to look at the enemy. These are those calculations right here. And the third value is always 0 because the game has a 3D coordinate system and a screen only has two, x and y. If you want to know more about this calculation, I have some good references at the end of my talk. I will upload the slides directly after my talk has started. Now that those camera angles are known, there's only one thing missing, and that's actually setting the camera angles programmatically from outside of the game's process. And for this, I've also used Cheat Engine again. There's a command inside CSGO to display all positions and view angles on the screen. So I've enabled this option and I've used Cheat Engine to scan in the memory for those view angles of my current player that are displayed on the screen. And then I froze those addresses. And now I couldn't move the crosshair in the screen. And then I've just unfroze half of my address list and I've checked if I can move the crosshair again. And if you follow this procedure, you end up with one static pointer to an address that contains the view angle, which you can just use inside of the hack. And you write a value to it and the game will just adjust your view to it. And that's a quick demo for the aimbot. It tries to automatically aim at the enemy's head. And if, of course, it's super unstealthy, it doesn't check whether an enemy is actually seen on the screen or if he's behind a wall. You would need to do some additional work here to make that work, but you can actually use it online. I've tried it you only get banned because people complain that you're cheating because it's quite obvious, but the anti-cheat didn't detect this external hack. So a few words about detection. Some people say VAC, or the Valve anti-cheat that's used for CSGO, is a joke because it mainly uses signature-based approaches to detect known cheats, which means that if you're using public code, you're going to get banned, but if you're using your own code, then it's going to be fine, as long as you're hooking functions inside of their middle. So it can detect whether a function gets hooked by checking the first few bytes at the prologue of this function. But if you're going to just hook existing functions in the middle of it, it's very hard to detect it, and currently that's the approach you're going to use. And of course you can also use all those fancy malware techniques like polymorphism or manual mapping, which you're using to implement the Windows API call load library yourself without actually calling load library. So you end up with your DLL being injected into the game, but it's not going to show up in the list of loaded modules. So you can use that to evade some anti-cheats. So that's it. If you have any questions, you can ask in the chat right now. Read my blog posts or all those references I've put on the slide. And don't cheat at LAN parties.
What the hell, man? Little Papa! Cheater! No way, dude! Dude, this guy's going! He's gone! Can't wait for the camera! Take your damn computer!
Yo and what's up? Welcome to my talk on game hacking. I do computer stuff and I also have a blog, and if you want to know more on game hacking and the stuff I'm going to present today, you can also read.
So there we are again. So this was the second talk, and yeah, one moment. I have to wait for a little bit of feedback here. Okay, so this was actually the second talk. We will start over at the RIP. Here I am again. At 12:30. It will start over then with hacking a smart coffee machine. That's actually the talk I'm interested very much in because I have coffee and I want next coffee too, and I want a coffee machine as well. So thanks actually to Philip Schmid, and yeah, thanks also again for our sponsors here. So BSides, Stuttgart, BSides, Airbus, Sias, Simon, Sushitsu, Google, Huawei, Mugway, ITSec, Kemet, Maltigo, and Zeitsaurus and the Schutzwerk, which we would have been very thankful to also create this here in physical form. I'm actually happy that we have actually done a virtual version of it, and also that our talkers and our conference people had the possible to say yes in a very short amount of time, because for everything, not knowing that. What we have done is actually we asked the people, so hey, you wanted to do actually a talk. We are very happy about that. Do you want to also do this in the virtual form? You have now 2 weeks to decide. And most of them, so about half of them, have said yes. We also were prepared for creating a second stream in parallel if there would have been the need of it. But we're happy actually for that it works out with one stream and the whole day with our 8 talks, and thanks to everyone helping there. We have now a 20 minutes break actually, so if you're interested in the next talk, make sure that you get back at 12:30. We have actually our Q&A still open for the talk 2. So just join the Slack if you like to. We are all there sitting around, drinking our coffee, eating our bread and breakfast maybe. So hopefully to see you there, and yeah, pause music. Hello again, there I am. For everyone not knowing what you're looking at, this is BSides Munich as a service, so actually a little IT security conference. Live in this case from Nuremberg, because I'm right now in Nuremberg. That is actually from the community made and created in Munich. And what you see here is the sponsors, which would have been our sponsors for the physical conference primary this year. So we actually changed it to community sponsors and the video again. And this is our daily schedule today. So we have our schedule from 12:30 to 13:50 with hacking a smart coffee machine from April. And I'm actually looking forward to it. I actually said that a few minutes ago already. I'm sitting here with my coffee. I'm very interested in how to hack my next coffee machine. Honestly, this is my next coffee machine. We will see. And yeah, I'm getting distracted a little bit from our Slack chat here on my second screen. If you're interested, please visit our Slack chat. It's actually linked under BSides, our website, 2020bsidesmunich.org. Hopefully to see you there. The good thing is that we have for each talker an own room. So you are able to just join those rooms and ask questions. And if possible, the people making here the presentations are also available and can respond to your questions. If this is not the case, we will have also FAQ provided, and we also can ask the people directly after this. So if you are interested in something which is part of the presentations and you want to know it, and it's not actually part of our talk rooms, just write an email to us. You can find it under 2020bsidesmunich.org. I'm happy for the day. I can just say ever and ever again, we have actually a wonderful team making this possible. Special thanks here also to Chris and Chen, so hello. And also thanks again to our sponsors, for our volunteers helping today with the chat, and for each presenter making this happen. So thanks and have fun with the next talk.
Hello, this is a talk about coffee. Actually, if you don't like coffee, it doesn't really matter because I don't drink coffee and I still work on that. It will also talk very much about Bluetooth, low energy, hacking, and this kind of stuff, of course. The other thing I wanted to mention before I start is that I like to do it in one single recording, so that it is like more live to you. But this also means that, well, you will see my errors live. And if I say something wrong, well, it will be live, and you know, it's the difference between that. Anyway, let's jump directly onto the topic. So it was a smart coffee machine, and actually there's a story behind that. And the story behind that is that I am one of the organizers of a CTF, which is called Foam. So I'll skip a little bit from the slides here and show you what this is. There's a reason behind it, right? It's not just pure advertisement. It's a capture the flag for smart devices, right? Which means obviously that we need to find challenges for connected devices. And those that we particularly look for are those which are on real devices, those that you can buy in a shop, kind of, no, right? And in 2017, for instance, we did one on a drone. Okay, there's a video here. I'll skip to the part where it gets, so there it is. You've got the drone and the participants had to make it take off. Here it is taking off in that case. In 2018, it was a robotics arm where the participants had to pilot that and open USB fridge to grab some Coca-Cola. Right, so we thought, well, okay, now we need for 2019 something like that, something which is visual but a real connected device, and we need to do a challenge out of that. And after some investigation, we came to this smart coffee machine. It sells for not that expensive, around 130 euros, okay, on the net. And the thing which is a little bit strange, perhaps, is that it has only some connectivity through Bluetooth Low Energy. You can't pilot it using Wi-Fi. This was perhaps a little bit surprising, or Ethernet connection, either won't work. It's not supported, right? So it means that you've got to get your smartphone, pair to the smart coffee machine and request your coffee and go and get your cup of coffee. Right? It doesn't come to you. And we thought, okay, well, I'm going to work on that, do some research, and find a way to do a challenge out of that. The first thing you do when you have Bluetooth Low Energy device is scan the various services that it has implemented and the characteristics. The service is kind of a container for various characteristics, and a characteristic is like this. It's a box, a label box. Well, this one has no label, sorry for that. Then there's a content. The label is kind of the address, the identifier of the characteristic, and the content is what you have in there, a value or something like that. That's basically how it works. And Bluetooth works by, querying the characteristics, so the boxes, and fetching data which is inside in the box, or putting data in the box. You can do that with plenty of tools. So this one is on the smartphone, NRF Connect. It is really handy, very good. You can also even send specific packets there to your BLE device. But if you don't want to use a smartphone, well, you can use tools on your laptop. So there are quite a few. Mirage is one that you might not know because it's not that well known, let's say, but it's really something that deserves to be better known, I think. So there it is, Mirage. I'm going to show you a little bit. Mirage Launcher. I type in my password, and there it is, and you have like a prompt here which is waiting for various commands. You can list the commands like that, list the various modules, sorry, that you have. And for instance, if I want to see here what kind of devices I have around me, I'm gonna load the BLE scan module, and then I can list the arguments that I could possibly set. So I can set, for instance, the interface, and I'm gonna run it. I run it, and well, you see, for instance, I've got here a smartwatch, which is close to my laptop. Actually, it's really very close. It's this one. And you can see other devices. I don't think I have very much there. It's got to wait for it to end. And if I want, I can query the various services that it has, and the various characteristics that it supports. For that, I first have to connect, and then to discover the services which are around. So there we go. The arguments are there. So, well, I don't want to target this MAC into MAC address, sorry, but the one of the smart watch. Don't worry, I know this is about smart coffee. It's just an example because I no longer have the smart coffee machine with me. So I'm just giving you an example. It's just the same with the smartwatch or any kind of BLE device, but we'll get to the smart coffee machine afterwards, don't worry. There we go, and I run that. Should be working. Yeah, connection time is there. And you see, it's pretty, maybe I can put that bigger. It's pretty neat because it gives you, well, all the services that it has. So there's a heart rate, for instance, service, and the characteristics of those. So this is the generic access service, which is a kind of standard. Device information service also is standard, and you get the serial number string for my smartwatch, which is there. Okay, so this is kind of the thing that you can do with it, with Mirage, and it's pretty cool. You can also use some other tool, which is called Bluetooth CTL, and this one is cool as well. So here, well, we see the MAC address of my smartwatch. That is because it had it in memory. But if we want to scan what we have, well, we put scan on and it's going to show what it has, and then I put scan off and then it stops scanning. Now I can start and connect to my smartwatch and type connect and the MAC address. Attempting to connect. It worked, okay, and yeah, and now you can see it automatically tells you all the characteristics and services which are on the smartwatch, which is there. Okay, so this is cool. This is cool. There is another tool, and I think this is perhaps the best known, which is called GAT tool. This one. But it is obsolete, okay? So if you ever go on a forum for BLE and tell them, oh, well, you know, something is not working and I'm using GAT tool, they'll scream and tell you GAT tool is obsolete, go and use Bluetooth control. And to be honest, it works better, right? Nevertheless, if you use that, it's just the same thing everywhere. You connect. I could have done it with another tool. I connect and I try to read a characteristic. And I get an error here. Read it attribute requires authentication before read write. This is pretty explicit. Well, it's explicit if you know how BLE works a little bit. There are several security modes. The first one is you have no encryption whatsoever, nothing. Level 2, you will have encryption but no authentication. Level 3, you'll have authentication and encryption, and actually there is also a level 4 with some elliptic curve encryption, but I've never actually seen that implemented in any device, but it exists, right? Okay. So if we want to get rid of this message, authenticate requires authentication. What we have to do is authenticate. So this is level 3. This is what is done through pairing, right? Now in GAT tool, maybe I can do it here. GAT tool. Well, it doesn't say level 1, 2, 3. It says level low, medium, and high. Low is a 1, 2, and 3. That's the way it works. Okay. With Bluetooth control, it's more explicit. It just tells you, you say pair, and it will work. Let's try with that device, that smartwatch. I'm not sure it will work, honestly. I'm just trying, okay? I'm attempting to pair with the smartwatch. And yeah, well, we have to wait a little bit, obviously. No, yes. That's one thing I need to mention, is that with Bluetooth, when something doesn't work, unfortunately, you sometimes have to try again, okay? It's not like it will work all the time, and that's the thing that makes it a little bit difficult. It's not just it works straight over all the time. It's not that, okay? Well, obviously it didn't work. I'll try again. Failed to pair. Okay. In progress. Okay, so it's already trying to pair, but it hasn't paired. Okay. Maybe I'm not able, maybe I'm already paired with another device on that smart watch possible, and it doesn't like it. I don't know. Anyway, it's the way to do it, okay? You pair, in that case, to the smart coffee machine, and if everything goes fine, you will get that pairing successful here. You can also do it with Mirage, and with Mirage what is really cool is that, well, you'll have to load the module which is called BLE Pair, But look at all the parameters that you can set. Actually, all the keys which are used in pairing, you can set them very specifically and set exactly the bytes that you want. You can also set your capabilities. Oh, I have a keyboard, I have a display, things like that. So this is really cool. Unfortunately, when I tried Mirage, that was over a year ago, well, I never managed to connect with Mirage to the smart coffee machine. Okay. Now, Mirage has very probably improved, or maybe I did it wrong. I don't know. I never managed to do it, but maybe it's better now, right? Then, well, we do that, and then we try again to read that characteristic that we tried last time, this one. And we get another error this time, which is called attribute requires authorization before read-write. Now, it's really important. All the teams in the CTS, well, not all, but most teams in the CTS got this wrong, and we're telling me, okay, I probably need to do something really specific with pairing so that I get rid of this message. Hello, this is a talk about coffee. Actually, if you don't like coffee, it doesn't really matter because I don't drink coffee and I still work on that. It will also talk very much about Bluetooth, low energy, hacking, and this kind of stuff, of course. The other thing I wanted to mention before I start is that I like to do it in one single recording so that it is like more live to you. But this also means that, well, you will see my errors live. And if I say something wrong, well, it will be live, and you know, it's the difference between that. Anyway, let's jump directly onto the topic. So it was a smart coffee machine, and actually there's a story behind that. And the story behind that is that I am one of the organizers of a CTF which is called Phone. So I'll skip a little bit from the slides here and show you what this is. There's a reason behind it, right? It's not just pure.
So, hello again. So, one moment. I have to ask something here. Just because I have the feeling that it just restarted. It's always a little bit hard to say how a talk is going on because most of the time I'm seeing the talk, but I cannot hear it at the same time because of my setup here. So it may have been that the video just restarted, but I'm actually not sure if it was already finished or it had just a little problem here. That's why I'm actually asking in the round of the talk 3 coffee. Okay, so the talk did restart. Okay, so we had a cliffhanger, I see. So then I have to take a look if it's actually possible for me for getting back to these to the video. One moment, please. Please just stand by. I will talk actually like I do it here. So this is actually our video. That's actually very nice.
Actually, if you don't like coffee, it doesn't really matter because I don't drink coffee and I still work on that. It will also talk very much about Bluetooth, low energy, hacking, and this kind of stuff, of course.
That's interesting.
The other thing I wanted to mention before I start is that I like to do it in one single recording so that it is like more live to you. But this also means that, well, you will see my errors live. And if I say something wrong, well, it will be live.
So it started from the beginning. Okay.
Yeah.
Yeah, it's always the same. You have a little bit of technology from time to time. So yeah, I'm actually going right to you again with my video. Beep. Hello. So actually we're doing something called a life hack. And yeah. Dun, 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 dun. This happens if you do things live, they actually from time to time just getting killed. I don't know why exactly. So we have here our 3 WebPressor, which is actually very fine. So okay, let us test if
Hello,
that works.
this is a talk
Okay, it
about
does not
coffee.
work. Oh no, okay.
Actually, if you don't like coffee, it doesn't
So
really
actually,
matter
we will
because I
start
don't drink
over
coffee
again with
and
this
I
scene,
still
seemingly,
work on that.
because
We'll
it's
also
not
talk
working
very
like I
much.
wanted that it should work. Yeah, happens. I hope it's fine for you. And we'll have to restart the stream at this point. So you have about 10 minutes, I guess, before we get back to the schedule again. I'm very sorry about that. These things happens from time to time.
Hello, this
See you
is a
later
talk
then.
about coffee. Actually,
I
if
have
you
actually
don't
not
like
the possibility
coffee, it doesn't
to
really matter because I don't drink
make the
coffee
video
and I still
going
work on
on where
that.
it should
We'll
do.
also talk very much about.
Seemingly. Let me see if I see something where I can do that. Nope, does not work like I wanted. Okay, so I'll have to stay there. I'm actually a little bit unhappy. Yeah. Okay, that's actually very interesting behavior here. Yep. We will keep going. Maybe if I find a fix, if not, we will have the possibility to watch it again now.
And well, you see, for instance, I've got here a smartwatch, which is close to my laptop. Actually, it's really very close. It's this one. And you can see other devices. I don't think I have very much there. It's got to wait for it to end. And if I want, I can query the various services that it has and the various characteristics that it supports. For that, I first have to connect and then to discover the services which are around. So there we go. The arguments are there. So, well, I don't want to target this MAC into MAC address, sorry, but the one of the smart watch. Don't worry, I know this is about smart coffee. It's just an example because I no longer have the smart coffee machine with me. So I'm just giving you an example. It's just the same with the smartwatch or any kind of BLE device, but we'll get to the smart coffee machine afterwards, don't worry. There we go, and I run that. Should be working. Yeah, connection time is there. And you see it's pretty, maybe I can put that bigger. It's pretty neat because it gives you, well, all the services that it has. So there's a heart rate, for instance, service, and the characteristics of those. So this is the generic access service, which is a kind of standard. Device information service also is standard, and you get the serial number string for my smartwatch, which is there. Okay, so this is kind of the thing that you can do with it, with Mirage, and it's pretty cool. You can also use some other tool, which is called Bluetooth CTL. And this one is cool as well. So here, well, we see the MAC address of my smartwatch. That is because it had it in memory. But if we want to scan what we have, well, we put scan on and it's going to show what it has, and then I put scan off and then it stops scanning. Now I can start and connect to my smartwatch and type connect and the MAC address, attempting to connect. It worked, okay, and yeah, and now you can see it automatically tells you all the characteristics and services which are on the smartwatch, which is there. Okay, so this is cool. This is cool. There is another tool, and I think this is perhaps the best known, which is called GAT tool, this one, but it is obsolete, okay? So if you ever go on a forum for BLE and tell them, oh, well, you know, something is not working and I'm using GAT tool, they'll scream and tell you GAT tool is obsolete, go and use Bluetooth control, and to be honest, it works better, right? Nevertheless, if you use that, it's just the same thing everywhere. You connect. I could have done it with another tool. I connect and I try to read a characteristic. And I get an error here. Read it attribute requires authentication before read write. This is pretty explicit. Well, it's explicit if you know how BLE works a little bit. There are several security modes. The first one is you have no encryption whatsoever, nothing. Level 2, you will have encryption but no authentication. Level 3, you'll have authentication and encryption, and actually there is also a level 4 with some elliptic curve encryption, but I've never actually seen that implemented in any device, but it exists, right? Okay. So if we want to get rid of this message, authenticate requires authentication. What we have to do is authenticate. So this is level 3. This is what is done through pairing, right? Now in GAT tool, maybe I can do it here. GAT tool. Well, it doesn't say level 1, 2, 3. It says level low, medium, and high. Low is a 1, 2, and 3. That's the way it works. Okay. With Bluetooth control, it's more explicit. It just tells you, you say pair, and it will work. Let's try with that device, that smartwatch. I'm not sure it will work, honestly. I'm just trying, okay? I'm attempting to pair with the smartwatch. And yeah, well, we have to wait a little bit, obviously. No, yes. That's one thing I need to mention, is that with Bluetooth, when something doesn't work, unfortunately, you sometimes have to try again, okay? It's not like it will work all the time, and that's the thing that makes it a little bit difficult. It's not just it works straight over all the time. It's not that, okay? Well, obviously it didn't work. I'll try again. Failed to pair. Okay. In progress. Okay, so it's already trying to pair, but it hasn't paired. Okay. Maybe I'm not able, maybe I'm already paired with another device on that smart watch possible, and it doesn't like it. I don't know. Anyway, it's the way to do it, okay? You pair, in that case, to the smart coffee machine, and if everything goes fine, you will get that pairing successful here. You can also do it with Mirage, and with Mirage what is really cool is that, well, you'll have to load the module which is called BLE Pair, but look at all the parameters that you can set. Actually all the keys which are used in pairing, you can set them very specifically and set exactly the bytes that you want. You can also set your capabilities. Oh, I have a keyboard, I have a display, things like that. So this is really cool. Unfortunately, when I tried Mirage, that was over a year ago, well, I never managed to connect with Mirage to the smart coffee machine. Okay. Now, Mirage has very probably improved, or maybe I did it wrong, I don't know, I never managed to do it, but maybe it's better now, right? Then, well, we do that, and then we try again to read that characteristic that we tried last time, this one. And we get another error this time, which is called attribute requires authorization before read-write. Now, it's really important. All the teams in the CTS, well, not all, but most teams in the CTS got this wrong, and we're telling you, okay, I probably need to do something really specific with pairing so that I get rid of this message. And I had to really give quite a few hints there and told them, no, you are already authenticated. You have paired successfully. Your authentication is successful. Authentication and authorization are two completely different things, right? You are authenticated. Your pairing has been said successful. You've got nothing more to do with pairing. You've got to do something after pairing that will indicate that you are authorized to access this or that service or characteristic. It's a very neat functionality of BLE. It is seldom used. I have seen this actually only on this smart coffee machine. And that's what actually made it interesting for the challenge in the CTF. That's why I used that. So how do I get authorization? Well, we know that as we are able to communicate with the smart coffee machine with a smartphone, we know that the smartphone has this authorization. It managed to get authorized. So what we are going to do is we're going to sniff all the BLE packets which are coming in or out of the smartphone and look in there, right? There's plenty of there are several websites indicating how to set this up. It's not complicated. And then I'm going to show you, well, what we get for the packet captures. So I'm exiting that. My packet captures are over here. Wireshark on its PQ Snoop Coffee. So this is a log that I got from my own smartphone. And we open this up and you see you've got this protocol, HCI command, HCI EVT. Now, either you know very well BLE, and then this is really, you know what that is, or you don't, and then, well, you can just search for it. And Bluetooth has its own protocol stack. And we can just kind of Google around for this stack and see hopefully things which are helpful to us. So well, this one doesn't show HCI, but we see L2 cap, which is here, at an SMP. Those are interesting. You'll see those afterwards. Yeah, here we see host controller interface HCI, which is there. Okay, so this is below SMP. SMP is the one which is called security monitor. I can't remember, protocol. This is where pairing occurs. So HCI is before, below, let's say in this tag. So it's not something that we will find, we won't find anything interesting there, sorry. So the easiest is just to sort through protocols, and we have ATT. This one is interesting actually. And then we have L2 cap packets which are there. And those SMP. SMP are the pairing. You say pairing request, pairing response, but we said that the authorization code would never be in those packets because it has nothing to do with pairing. Okay, so it has to be above. Above, well, we said no. L2 cap is not above SMP, so we could have ATT or GAT over there, which are roughly at the same level over here. So we're going to look into that. So we're going to look at the first view. And here what we see is what the smartphone is going all the time to try and discover all the services and characteristics that it sees on the smart coffee machine. That's the way it does it, and that's the way all devices that communicate with the BLE device do. So the first few packets are not really interesting because they are discovery packets over there, find file information. Do I have anything in those handles or not? Yes, we've got this or that. And it's not what we're looking for. What we're looking for is, well, the authorization code has to be sent after this discovery, but before we actually managed to brew our first coffee. Okay, so it will be just after that, probably. Oh, there, look. This one is changing a little bit. Here we are sending a read request, and we get the response 02. Okay, why not? Write request. This time we are writing something over to the smart coffee machine. And what could we possibly write if we are not yet asking for a coffee? Well, you've got it. It is the authorization code. Okay, to be honest, if you really want to find this out, you probably have to do a few tests. I've shortened the path of finding it, but there it is. This is the authorization code. By the way, it changes every time you reboot the machine, and it's different on every machine. So if you have the same coffee machine as I have, it's useless just to copy paste it. It's not going to work. Okay. So we've got it. That's pretty cool. Now that we have got it, well, we are able to read all the characteristics that we want. So now what we want to do is to brew our own coffee. We want to get some coffee. And for that, well, we are going, that's the way I did it. Well, I took the application, the smartphone application there, and reversed it and tried to understand what commands they were sending to the smart coffee machine to get their coffee. And at some point, I found a very interesting class, which is called brew operations. And now I'm going to switch to this. This is Jeb. This is a reverse engineering tool for Android and for other platforms, but it's pretty good for Android. And we are looking in the brew operations class. Now again, I am really shortening the time frame here. It took took me several days to find out that the interesting part I was looking for would be in brew operations, okay? Usually what I do is I work my way from the methods which are actually communicating with Bluetooth and sending packets to the characteristics, and then I see who is calling those and then who is calling the caller, and I work my way up through the stack to understand what are the important points. And here in this part there, in brew operations, you can see all the fields, there's quite a few, and the methods that it has implemented. And there are some pretty interesting methods. This one, for instance, write brew now, or write brew with temperature, or write recipe, or write schedule brew. Let's have a look at this one, for instance. Well, we see that it needs to be authenticated. Okay, well, we knew that. And then it is going to write a BLE characteristic. It will write to a BLE characteristic. Which one? Well, this one, actually. And this one is defined over here at the top of the class. It is here, it is instantiated here, and we have its service UUID and the precise identifier for this characteristic. Okay, so we know exactly which box it is going to look into. Let's go back to the code. So it is calling that characteristic, and it is sending this payload, and the payload takes 0 and coffee type ID. So this is interesting. We see that 0 obviously is the time. Okay, so actually it tells the coffee machine, I would like to brew coffee in 30 minutes, in 1 hour, in, I don't know, 2 hours or something like that. And the coffee type is it a ristretto, is it an espresso, is it a lungo? And we see that the way it works is that, well, there's a fixed prefix, 3, 5, 7, 4, that's what it will send, those bytes. Why? No clue, it's like that. Then the time will be 4 bytes, and then 2 bytes for coffee type. That is the way to actually get your coffee. And actually I can show you that it works. I've got a video for that. And here I'm going to request a ristretto. I'll explain about this website a little bit afterwards. I think, yeah, I asked for a ristretto, and you see there it is working, and it is getting my coffee. And this website actually does the BLE command, which gets to the smart coffee machine and commands it to get my coffee. So that's how it works. There we go. So those are the slides. The coffee type, yeah, I hadn't shown you the coffee type, if you want to have a look at that. Coffee type is in this class, sorry, over here, in this class. And for instance, this method shows us that ristretto is coffee type 0, espresso 1, lungo 2. And then we've got some additional ones, Americano and hot water, but those are only, you see, from expert brew parameters, those are only for a specific coffee machine, not the one that I actually had. So those are not working on all coffee machines. Okay, so this is how we can set the coffee type. So we know how to send a command to the coffee machine to get our coffee. We could have got it also from the packet capture. That's another way to do it. So let me find it. So I said we are going to send something to handle 24. 24. Got to find one. There it is. So you see here we send 03, 05, 07, 04 and zeros. So this means that we were requesting immediately for 1 coffee because the time is 0, and the last 2 bytes are 0 as well, which means I was asking at that time for a ristretto. Okay, that's also how it works. So it's interesting, different ways to work out what is happening, but reverse engineering the smart application is, of course, gives you lots of information there. So then, well, that's what you saw in the video. I did a web interface there. That's because actually, normally, you just do it with your smartphone. And if you want to pilot the smart coffee machine, you need to be paired. But then think if one of your colleagues, if you're in a company, okay, and you want to share the coffee machine with colleagues, well, your colleagues are going to have to do a special combination on buttons on the smart coffee machine to unpair the previous colleague. Then they need to pair their smartphone to the coffee machine and then to request a coffee. Okay, this is really too complicated, or in a family it's really too complicated. So I thought I'm going to simplify this process and share the coffee machine by using one of those new Raspberry Pis. And the Raspberry Pi is going to act as the only one which is connecting to the smart coffee machine. And it will be the only one doing the BLE packets to the smart coffee machine, and the other ones, every other person in the company or in the family will just have access to a website which is on the Raspberry Pi. And that's what I did. Okay, so we can request a ristretto, an espresso, or a lungo, and well, it works. Basically, we can get what we want from the smart coffee machine. You might notice here that we can actually also configure the cup size. Okay, normally a ristretto, for instance, is 25 milliliters, but actually you can configure that a little and do anything between 15 and 30 milliliters, right? And so this is pretty cool. This is something that I found while I was reversing the application in the cup size operations class. So it is here. Cup size, well, you see that there is a service, a characteristic. So there's one for cup size and one for volume. And then, yeah, sorry, I didn't show you. We get the complete description, identifiers to get to those characteristics. Then if we want to modify, for instance, to configure the cup size, well, we see that we need to be authenticated. And then that we have obviously to set the cup size type, and also the cup size volume. So we need to say, okay, I want to set a ristretto to something else. And then the volume. The volume, this is how it works. It's implemented here. Well, we write to a given characteristic. This one, volume characteristic. And this payload, get cup size volume data. And we see that this is the volume, 2 bytes, and then -1, so this will be FF behind that. And for the coffee type, well, we see that it's perhaps just above. To set the cup size, the payload is get cup size kind byte buffer, this one, and we will basically just set 0, 1, 2, the various cup coffee identifiers for the cup we want to specify. So that's how we can actually customize our cup size, and this is pretty cool because the standard application does not have this feature, right? So this is something which is actually in the code but hasn't been made available through the application, so we are able to hack our coffee machine that way. And that's one of the things with the last challenge that people had to do in the CDF to have this coffee machine. So if we want to do it, we have to connect to the smartphone, to the smart coffee machine, pair, get the authorization, then specify which cup we want to customize, then set the volume, and then finally we disconnect, and then it persists over time unless we specify something else, a new volume, and then we change the settings. There are a few limits though, and this is good because you can't set whatever volume for a ristretto. Ristretto has to be in between 15 and 30, things like that, which is pretty good. So I'm going to show you also this video for that in action. So here I am trying to get a coffee which will be with 70 milliliters, right? And for that I am configuring the size of a cup, which is the longo, and saying it should be 70 milliliters. Now, if you have a close look, here, this is the normal volume for an espresso, this is the normal volume for a ristretto, and this is the normal volume for a lungo. You will see we are going to end up in between. There you go. You see, so we really did have 70 milliliters here. It's not quite a longo, it's far more than an espresso, so we really managed to hack the coffee machine and customize the cup size in that particular case. So it worked, and that's good. What else? So at phone, 17 teams managed to find the authorization code, and well done, because it's not that easy. I mean, at first to understand really how BLE is working. One team managed to brew some coffee without using the smartphone application, the standard application, and then one team nearly managed to customize the volume, but they didn't finish on time. You only have, like 8 hours there at phone, so of course, and plenty of other challenges, so it's always, you've got to be very quick, and it was a bit short, right? But really good results there. If there's some feedback there about using BLE, and you have some BLE device that you want to hack or do some research on, what I would have to say is that I encountered really crazy bugs with sometimes connecting and disconnections, they weren't expected, things like that. And all of this disappeared, well, most of it disappeared when I upgraded my stack to Blue Z 5.5. So really it's important, upgrade to one of the latest stack there, which is perhaps not the default one that you have on your system. It's really important because there are really lots of bugs and more stability with the new ones. Also, I really did like Bluetooth CTL, which is a tool I hadn't really used before, and I think it is nice. It is interactive, and in my code, so my WebPresso, my web interface, that I am using this one. Sorry. Yeah, this one, I put all the code on GitHub. So let me show you, here. It is GitHub, Cryptops, WebPresso. Feel free to use it, it's shared. And you have all of that. Basically, the web interface is used with Flask. It's very simple because I'm not very good at web interfaces. And then the web interface basically just calls one script, which is called brew.sh, which is a script written using expect. And expect is really quite interesting because it's particularly done to pilot interactive tools, and this is really perfectly suited for Bluetooth control. So here you say, for instance, that Bluetooth control has a prompt, which is going to be hash. Okay, you launch it, and then you send, just like you were writing, connect to the given address in Bluetooth control, and then you tell it, okay, expect this or that answer, and depending on that, do this or that. And this is just helps you work with an interactive tool, and I really like that. Otherwise, it would have been kind of difficult to do it. So, yeah, this is something else which is really good with BLE. Also, I found it pretty good that the smart coffee machine had buttons, physical buttons on it, and special combinations to unpair or do a factory reset. This was really extremely helpful during phone because well, we were able between teams to reset completely the coffee machine in a standard and normal situation. Otherwise, it would have been a nightmare because a team could have, put the coffee machine in a strange status, and it would be very difficult for the next team to play with it. So that was cool. The other thing also is that if you have such a coffee machine or another one which is really similar, well, you find lots of documentation on the web, like really detailed one there where you have exactly what is inside. You have also teardowns of similar coffee machines. You can easily find replacement pieces of the coffee machines on eBay. For instance, you can find a new flow meter or the PCB here which handles the buttons. This is cool because it makes it repairable, and in an area where it was sometimes we kind of throw things away, well, here if you want to repair your coffee machine you can, and I find that pretty cool. Before I say thank you for your attention, although I do say it, I can show you also another short video with the interaction with the smart coffee machine. You can also get the error messages from the coffee machine, and that is cool because it gives you some information of what is happening. And this is one of the case. So I was asking for a ristretto here, and it tells you the slider is open, please close it. So the slider is the part where you insert the coffee capsule, and this one had been left open and hadn't been closed afterwards. So it tells you that kind of message. Well, actually it gives you an error code, and then you translate that to an understandable message. So that is good. So as I said, thank you very much. You have the URL here if you want to go and see my code and use it for your own coffee machine. Of course, you are welcome to come and play to phone. It is in the south of France, and normally this year it will take place in January of 2021. And lots of kudos to other phone organizers, and thanks again also to BSides Munich organizers for giving me the opportunity to speak through this video to all your attendees. Bye-bye, thanks.
So, thanks here for the third talk we had. As you may have noticed, we are a little bit over time right now. That's basically because, we had, or in this case, me had a little problem with the setup for the videos. So we are jumping right into the next video. In this case, OWASP API Security Top 10 from Frank Olai, which is now about 15 minutes over its time. I hope that's fine for you. We will jump right in it, and thanks for hacking a smart coffee machine. I know what not to buy now.
Hello, this is a talk about coffee.
Hello and good afternoon, BSides Munich. My name is Frank Uli and I'm a senior penetration tester and security consultant with One Consult Deutschland GmbH. We as the One Consult Group do offer security consultancy services and are originally from Switzerland, and our German offices are located in Munich. And today I'm happy to talk about the OWASP API Security Top 10, how APIs are hacked and how to develop securely. And I start by giving an introduction to the OWASP as a project to those of you that don't already know them, and the fact that there was an original top 10 list and still is aimed at web applications, why there was a need for a new top 10 list aimed at API security that was published recently at the end of 2019. I'll then get into each of the risks on that list and conclude with a summary about the root causes of these issues and how they might be mitigated. And finally, after this presentation, you can find in the appendix of the slides that are of course available a large number of resources that I compiled about API security in general, but also about specific issues mentioned in the top 10 list. I'll begin by giving a brief introduction into what the OWASP and the original top 10 is. OWASP stands for Open Web Application Security Project, and since 2001, this non-profit organization aims at improving the security in the web. And probably the most well-known publication is the OWASP Top 10 list, which contains the 10 most critical or 10 most widespread issues found in web applications. And while I won't go into detail of any of these items of the original Top 10 list, if some or more of these terms does not ring a bell with you, for example, what insecure deserialization is, or XML external entities, I highly encourage you to look into that original web top 10, since these issues might also arise in an API environment. But first of all, why the need for a new list? In the conventional days, the majority of work was done by the web application running on the server in the middle. But in modern ecosystems with microservices and RESTful APIs, actually, a lot of amount of work is done in the client side, either being a single page applications running in a web browser or mobile applications for iOS and Android. And depending on which statistic you asked, the majority of web traffic is now API traffic, but there is some kind of distinct differences between the conventional model and the modern model now that applications themselves query different APIs in different environments, and thus the new top 10 list. So the first item on that list is broken object level authorization. And this occurs if privileges of authenticated users are insufficiently checked at object level. And thus attackers may be able to change an ID to that of another user and thus gain unauthorized access to data of other customers. And we take this example of rating a talk that you've registered to attend. If this is implemented this way, simply pathing through the ID of the talk and the rating in the back end, and if there's no check if the attendee actually registered for the talk, then anyone can vote for any talk regardless if he did attend it. So what is the result? Data of other users is exposed. If this is a multi-tenancy environment, data of other tenants might be exposed. If access to data of other users is possible, this is called horizontal privilege escalation with roughly the same amount of privileges. But it might also be possible by this vulnerability to actually do vertical privilege escalation where one accesses higher privileged data. How can one identify this vulnerability? Dynamic application security testing is one of the main drivers to find this vulnerability, which I'll talk about in the next slide, but you can also do manual testing of the application and the API. And of course, you could also look at the static side of things where you're not looking at the running application, as with DAST, where you're looking at the source code and try to identify vulnerabilities. And if you're trying to do dynamic application security testing, this is the classical approach where the application now, in this example, a single page application, talks via the cloud to the different APIs in the web. and you as an attacker now insert an interception proxy such as burp or the open source zattack proxy and can now manipulate requests made by the application, but also you could manipulate and also view responses sent back to the application by the API server. So what could be done to prevent this issue? If you Google for this, you will come across solutions that don't really solve this problem. For example, blog posts might say, don't use such easily guessable IDs, do generate UUIDs. However, by using UUIDs and still not properly enforcing authorization checks, an attacker that knows the UUID might still be able to access this object. So the only solution is recheck the authorization for each reference, and ideally you would implement a decision engine, for example, that now does try to verify if this user is allowed to edit this user, if on the object level this user is allowed to see this object, and for administrative actions if this user is allowed to delete this object. So the second item is broken user authentication. And this issue arises when authentication and session management is not properly implemented. An attacker might be able to log on unauthenticated, impersonate other users, or steal passwords or session information. And why is this the common? Well, there are a large number of endpoints in APIs, but there are also distinct endpoints having to do with authentication, such as forgot password, logon, or mobile logon, that do require special protection, such as a brute force mechanism preventing password guessing attacks. And if these mechanisms are missing, there are now weaknesses and vulnerabilities. But the other main cause has to do with misconceptions and misimplementations of newer technologies being used. For example, if one uses OAuth flows to make authorization assessments, there are various parameters that can be configured insecurely. There are, of course, classical issues such as passwords being saved without proper cryptographic measures. An issue I want to talk about in more detail is when JSON Web Tokens are used improperly. For example, JSON Web Tokens you would get back if you used an OAuth flow to authorize to your application. So it isn't JSON Web Token, you might have encountered them. JSON Web Tokens are self-contained tokens that in themselves contain all the claims and data necessary for an endpoint of a microservice architecture, for example, to make decisions whether this request is authorized or not without having to store session information on a central server, for example. So this is in contrast to classical session tokens that are reference tokens. And if you had a look at one of these JSON Web Tokens, you might notice that there are three parts. There is a header which contains information about the algorithms used, the main payload containing claims about who this user is and what his privileges are. For example, this user is not an admin, but also standard data points such as when this token was issued at and when it will expire. And in this solution, the security arises from the shared secret that's used to create the signature. The secret needs to be shared between the endpoints that issue the token and all endpoints that consume the token. And if we now take a step back and think about this for a second, you might notice some things right away. For example, the payload, the body of the token, is not really encrypted, it's base64 encoded. So if there are some truly sensitive information such as social security numbers or even detailed birth dates, they are not properly secured. Second of all, an attacker can take a JSON Web Token, stuff it into a brute forcing program such as John the Ripper or Hashcat, and try to offline brute force guess the shared secret used to create these tokens. And if the secret is not strong enough, an attacker can guess this secret and now forge his own tokens. But in the early days of JSON Web Token libraries, but also if you would roll your own implementation of them, which is highly discouraged, if one implements the JSON Web Token specification to the letter, there is such a thing as the non-algorithm, where you can simply remove the signature and still have a valid JSON web token signed with the non-signature. The result will be privilege escalation and counterfeit tokens if we're talking about JSON web tokens, but if we're talking more generally about issues in this area, unauthorized access to data and unauthorized access to actions. So how would one identify the issues? By taking a bird's eye view of authentication, by asking yourselves, well, how are my users authenticated? How are passwords stored and transferred if I do that myself? How is the user identification developed and managed? And are there actually strong guarantees about the identity of the user being used? And in detail for the JSON web token example, you can do dynamic tests by manipulating parts of the JSON web token, the signature or the header, or by doing static analysis. For example, if you have a look at your code, you should always make sure that you hard code the algorithm used and that you actually validate the JSON web token if it's still valid at the time it's consumed, and not simply decode it. And you should use a strong secret. So what are measures in general? Credentials and session ID should be protected. You should use standard mechanisms across the board for your entire solutions that are tried and true. If you've not followed the latest developments in password recommendations, I encourage you to have a look at the NIST 863 that talks about newer ideas about password complexity and password safety. Of course, you should enable your users to use a second factor if they wish so. And if you have to do with JSON web tokens, if your application consumes or produces them, I encourage you to look at the IETF draft talking about the best current practices. And of course, authentication not only is the login, there are other parts such as registration, user name recovery, or forgot password functionality that can have weaknesses that lead to the compromise of the applications, so you must take a look at them also. The third item is excessive data exposure. And while this issue is not specific to APIs, it's more prevalent because API-based applications provide a lot of data that is often first filtered by the client, and this data is also visible to an attacker that intercepts and manipulates the traffic. And thus an attacker may gain access to confidential information, for example, addresses or account details. And why is this so common? Well, the REST and API ecosystem encourages developers to implement APIs in generic ways. For example, simply taking an object and outputting that as a JSON string. And if the filtering is done on the client side, for example, of this user profile that on the client only displays the age, but actually transmit the birth date, an attacker that does have a look at the traffic now knows potential sensitive data. And of course, you can imagine data even more sensitive than the birth date. So the result will be disclosure of sensitive data and ultimately financial loss and damage to reputation. How could you identify such issues? By again taking a step back and by classifying your data, by tracking down where your application will create data up until the point where it will no longer need the data and when the data will be archived or possibly destroyed. By asking yourselves, well, which data is worth protecting and where and how is this data transferred and stored across the entire board of your solutions and also across possible third-party systems, and two, in terms of user privileges of the applications, but also as technical user privileges, such as database account users should really be able to read or change that data. And of course, you can do dynamic tests by inserting an interception proxy and checking if your API exposes too much data. And at the code level, you can have a look for, depending on your framework and language, to remove generic methods that simply generate a JSON string, for example, with all the object properties. And more generally speaking, data should be protected or encrypted at each step, at rest, at transit. But newer technologies such as HTML5 APIs like session or local storage do enable developers to store data on the client side, but this data by default is stored unencrypted in the browser and is also accessible by every JavaScript originating from the same origin. So do protect data at every step sufficiently. So number 4 is lack of resources and lack of rate limiting. What does this mean? Well, if an API is not protected against a great number of requests or large payloads by implementing rate limiting or by rate limiting that is easily circumvented, attackers can execute brute force attacks, for example, on user accounts up to denial of service attacks. So what would be an example? This is a log-on endpoint where you pass a login and password, and of course if there is no brute force protection, an attacker could try to guess the password. However, this example application has implemented some standard conform rate limiting where rate limited header are given back containing information about what is the rate limit, how many tries are left for this IP address, and when will the rate limit be reset. However, there are infrastructure headers set by components such as reverse proxies or API gateways containing information about the original IP of requests that have passed through a larger environment, for example x-forwarded 4. And if an attacker is able to insert these headers, now he has circumvented rate limiting by telling the rate limit mechanism, well, I'm from this IP, where in reality he's not from that IP. On this is an issue we see a lot in penetration tests. So brute force attacks are not prevented. Data may leak by an attacker simply requesting all data accessible to him and harvesting them, ultimately leading to unauthorized access to data possibly, and denial of service if the system does not limit payload size. For example, if it accepts arbitrarily large file uploads, then it then tries to interpret at the backend side, creating denial of service vulnerabilities. These issues could be identified by accessing the application in a different ways, unauthenticated, authenticated with incorrect credentials, and always making sure that there is a rate limit in place and trying to circumvent that rate limit by adding headers such as x-forwarded 4 and observing changes in responses, observing changes in response time. So measures that should be taken: you should implement rate limiting for your API. 4 to 9 is a standard response. You should also implement a payload limit, talking about the size of the payload or the number of seconds or CPU amount of time that payload is processed in the backend. And you should never trust user input. Malicious user input or malicious input in general can not only be in parameters, but also in header fields. And headers that are affected by this issue are, for example, also x-true client IP or x-real IP. But as these headers talk about the origin of a request, conversely, they are headers set by infrastructure components such as x-forwarded host containing information about the target of a request. If an attacker is able to insert these headers and these headers are interpreted, there are other attacks possible, such as web cache poisoning. So never trust user input. Number 5 is broken function level authorization. And this means that privileges of authenticated users are insufficiently checked now at the function level, in contrast to the object level we talked about earlier. And if an attacker is able to modify the path or method of a request, he might be able to reach privileged API endpoints, thus gaining access to administrative functions. And why is this so common? Well, in the olden days, developers were free to put, for example, a request to delete a user at an arbitrarily selected complicated path, such as the one pictured above. But in the modern API world, with RESTful development paradigms, if an attacker sees that a normal function to request a user is get API user ID, it's easy for him to guess that, well, if this is a RESTful API, the endpoint to delete this user might be by changing the HTTP verb to delete. The result of this issue is exposure of high privilege functions and possible vertical privilege escalation, as we talked about earlier. So measures in general to prevent these kind of authorization issues. Well, access to functions should firstly always make sure that the user is authenticated. API endpoints should be not accessible, access should be denied by default, except for resources that truly need to be public. And it has to be made sure that the user has the required role to access and execute the current function. And also, generally speaking, for access to objects, it has to be made sure that the user has access authorization either by being the direct or indirect owner of that object, and indeed also if he can access the object in the way he's currently trying to do so. He's trying to create, read, update, or delete an object. And most importantly, not relying on client apps to enforce any kind of authorization checks and to check authorization at the server for each reference. Point 6 is mass assignment. And while also not new in the web world, it's more prevalent in APIs because frameworks automate the conversion of client input into object properties. And if that's possible, an attacker can override possibly certain properties, thus gaining higher privileges, manipulating data, or bypassing security mechanisms. And in the example, there is an API that creates a user with a username. And if in this kind of pseudocode, this request body created by the user is simply passed to the database, well, then an attacker that can guess or infer by having, for example, the previously mentioned vulnerability excessive data exposure, an attacker that can guess that there is a parameter role containing authorization information, he or she might be able to insert this parameter and thus create an administrative user. How can this issue be found? It can be found by code reviews and by dynamic tests, and can be prevented by not automatically binding input from the client into objects, and prior to that, defining and allow listing expected parameters and values, and possibly protecting properties that should not be changed by making them read-only. And more generally speaking, by defining schemas, types, and patterns for the expected inputs of the application. Number 7 is the umbrella term security misconfiguration. And this is one of the main causes of real-world security breaches and the most common finding in penetration tests. And this has to do with the fact that security is not only depending on secure coding practices, but also to a large degree on secure configuration that might be insecure, in fact, or that might be default configuration that is not secure by default. And depending on the impact of the risk, attackers might benefit from information about components being used to be able to further their actual attack up to complete compromise by the fact that a simple security misconfiguration is present. And this talks about, generally speaking, the fact that the attack surface of the application is larger than it needs to be. For example, defaults, passwords are being used, or any kind of unnecessarily attack surface is exposed. For example, ports or services open or running that are not necessarily to serve the business purpose, accounts being used that are by default, directory listings being enabled as 3 buckets if you're talking about the cloud environments being insecure, and so on. And the result will be data leakage. An attacker might benefit from simply executing exploits for publicly known vulnerabilities, unauthorized access to data, up to, as I said, complete takeover of the system. And these issues can be identified by doing regular vulnerability scans of the entire environment. And a specific vulnerability, due to time reasons, I cannot get into in detail, but I encourage you to be aware if you are using the underlying mechanism as cross-origin resource sharing. That is a mechanism to lessen the security guarantees by the same origin policy implemented in the browser to enhance APIs talking to each other about different origins. However, there are a number of misconfigurations that can arise with CORS, but there are tools such as CORS Scanner or Corsi you can use to run against your live application to check if these issues are present that are specific to APIs. Generally speaking, what can be done? Unnecessarily functionality should be disabled. You should implement a repeatable hardening process according to good practices for each component and layer of your solution. And ideally, you should use the same secure configuration for your development, test, and production environments. And generally speaking, segment your application architecture as much as possible and do automated tests of configurations and settings across all of your different environments. Injections, while being the number 1 item in the original web top 10, are only rated at place 8 by the API security top 10 authors. Generally speaking, injections happen when data is interpreted and the interpreter does not clearly distinguish between code and data, and it's possible that data is interpreted as code, and thus attackers may steal or modify data or execute code in the context of the application and thus possibly take over the system completely. And while there are some type of classical injections such as SQL injections that the API security top 10 authors argue are far less common today, with modern frameworks preventing developers from making these mistakes in the first place, there are, of course, a number of interpreters in modern applications, NoSQL databases, XML interpreters. Applications do make LDAP queries or SOAP queries where injections are possible, so this is still a large attack surface. Solutions to identify injections are twofold. On the one side, doing a static analysis, having a look at the code and making sure that for each interpreter there's a clear distinction between code and data by the appropriate mechanisms, but also augmenting this with tests of the live application and using manual or automated tools that do test the running application. Generally speaking, what are measures to prevent injections? Input validation should be one thing that your application should always do, including validating data that comes from your own systems or systems you have a trust relationship with, because these systems might be compromised too and not send you reliable, trustworthy data. Also, you should think about strictly defining all input data, expected format, expected values, possibly even allow listing only certain values, and you should make sure that the transfer from the data to the interpreter is secured appropriately. One example that prevents most SQL type injections would be to use prepared statements. And finally, a defend in depth measure would be to use output encoding suitable to the context where the data is placed and suitable to the interpreter that prevents meta characters inserted by attackers from being actually interpreted. The second to last point is improper assets management. And this issue arises when vendors lack an overview of existing systems, versions, or endpoints, and in case a vulnerability is detected in the latest version or release of the API, these older endpoints or versions are not retired or patched. And thus an attacker might be able to access data that originated from the production systems but was copied over for testing purposes to a quality assurance environment, which it compromises with the old unpatched vulnerability and now has access to very valuable data. The causes are that APIs are changing constantly due to continuous integration and continuous development and the generally accelerated pace of development in modern agile organizations. And if there is, for example, missing documentation that in version 1, for example, there was a get all users endpoint that might have been even accessible unauthenticated, attackers have now found an interesting entry point into your environment. Another example might be unknown API hosts, a quality assurance development environment where data from production was copied over to fix an issue, the data being forgotten there, and now with an older version of the environment exposing weaknesses, an attacker compromising that and stealing very valuable production data. Measures that can be implemented to prevent this might be to inventory hosts and document API versions, to separate production and test and development environments as much as possible, ideally to not use productive data in these other systems, but still to apply the same security measures in all environments to get to know how they work and how they might interfere with business functionality and how they might have to be tweaked. But also to network and API firewall your endpoints sufficiently also from requests stemming from internal systems that are not expected to make these requests. So to apply a healthy amount of what is called defense in depth. And finally, to force authentication in front of application exposing sensitive data or dangerous or powerful functionality, also if this is only an internally accessible service. The last point of the top 10 is insufficient logging and monitoring. And it's written in cursive because this is not strictly speaking a weakness, but more of a lack of technical and organizational protective measures that, when not in place, enable attackers to carry out attacks without being noticed, or in case incident or data leak is suspected, it makes it difficult to reconstruct if and which data was leaked. So while this topic could fill an entire talk, the root causes are that there possibly might not be logs for each component of the solution. Logs that are available are insufficient or are only stored on single machines and not sent to a central server where they can be monitored and automatic alerts can be fired for certain suspicious behavior. And if there is no incident response process, if there is no documentation about what to do in an incident, and if this has not been rehearsed, and then if there is some kind of issue with the application and a security incident is suspected, panic arises. So which measures should be implemented? Well, errors particularly during authentication and authorization should be logged on a central server. There should be enough context to identify suspicious accounts and activities, but no sensitive data such as passwords or access tokens should be logged, which would make the logs themselves now an interesting attack surface. You should use a simple and unified log format, and ideally you would implement automatic alerts and create and rehearse a sufficient incident response process. So, in conclusion, some of the main reasons for security weakness and possible corrective actions. To prevent injections, you should do a healthy amount of input validation regardless of the source of the input, even if it's a system you would consider trusted, and to also encode output created by your application suitable for the context that it will be sent to. Do not place too much trust, especially in your client applications. Always make sure that security critical validation steps are taking place server-side, and with every access to functions and objects, make sure that the current request is authorized to do so. To prevent issues introduced by the growing complexity of systems, you should introduce standardization as much as possible. For example, decide on one platform for identity and access management across your entire solution and environments, to document your design decisions and configurations, and to, of course, to automate as much as possible. And to combat a lack of defense in depth, you should isolate components of your own infrastructure from each other as much as possible to prevent one intrusion in some parts of your application somewhere in the cloud to spread across your entire solution or environment. So having all that, Is the OWASP API Security Top 10 a panacea to combat weaknesses in your APIs? No, it's a good practice document containing information about the 10 most critical risks as identified by its authors. It's a good first step if you want to make your API-based applications more secure, but it's intended on purpose as an awareness document to be read once. It's by no means a comprehensive standard that, if followed, guarantees security. It's, so to speak, the bare minimum to avoid negligence. So which publications does the OWASP have to offer if you want to take a more comprehensive approach to securing your solution? Well, if you want to do security-minded code reviews, there's the code review guide. If you want to dynamically test your applications, there's the OWASP web testing guide. The most current version is 4. Version 5 is in development, which contains very much details about vulnerabilities, how to spot them with dynamic or static analysis that is also very relevant to APIs. If you want to more take a preventive approach, for example, as a developer, you can have a look at the OWASP proactive controls that contains 10 items such as input validation and outlines what this means, what implication this has, how this can be implemented, and gives hints about possible libraries according to your environment and language. And finally, if you want to take a more holistic approach, you can have a look at the OWASP Application Security Verification Standard, ASVS in short, where you decide, well, how important is the data that my application processes, which security level should I aspire to, and then the ASVS contains detailed checklists for each step of the software development lifecycle, beginning from design to really concrete implementation details, where you can have a look at and use the checklist approach to develop your applications more securely. And with that, I want to thank you for your attention. These are my contact details, and you can contact us at OneConsult with this data. And in the appendix of this presentation, as already mentioned, you find a number of resources that hopefully give you an even deeper insight into API security. Hello.
Hello, and there I am again. Welcome to BSides Munich as a service for everyone new. Here you see our sponsors for this year. On this scene you see also what are we going to do next. For everyone not knowing, we are actually 6 minutes over our schedule right now because we had a few little technical problems. So we will jump right now into the next talk, which is the 5th talk for today, which is from Pablo Andres. Thanks also to Pablo from myself, because he was one of those people also very specifically very short-term available for a talk. And yeah, I'm also very much into the IoT stuff as well. Everyone not knowing me at the BSides Munich 2018, I guess. I have been one of those people creating also the CTF, and the IoT CTF was also one of my personal favorites to create, because it was for me also very, very nice learning. And I hope to learn also from the talk now how to shield the IoT product from the OWASP IoT Top 10, where also Pablo is one of the most recognized people also. Yeah, so have fun there.
Hi guys, this is Pablo, and I'm going to be talking about IoT security. So let me flip over to my slides. All right, so we're going to be talking about how to shield an IoT product from the OWASP IoT Top 10, or how the S in IoT stands for security. Okay, who am I? I'm a security professional or a hacker, trainer. I've been working in security for the last 15 to 20 years, depending on where you start counting. I worked on defense, offense, and I just enjoy doing security. In my free time, I like doing Shotokan karate and slacklining, especially right now in the summer. Okay, I work for 7 Shift, which is a company I founded around 3 years ago, and we're a boutique security company focusing on cybersecurity and IoT. Normally, we work with security testing devices, applications, mobile applications, and whatnot. When we're lucky enough to get called into the beginning of a project, we actually try to help our customers implement security by design. We help them with certification to achieve security certifications and whatnot, automation. And then we do trainings, public trainings at least twice a year, normally in May and November, more or less. And we do trainings on IoT. We have 2 hands-on trainings, which are these 2, the IT Security Bootcamp and Assessing and Exploiting Control Systems and IIoT. We need a new name for that, it's just too long. But these are hands-on trainings where you will be hacking on devices, PLCs, wireless hacking, hardware hacking, and we have a training that is more for your theoretical part, where we talk about security strategy, threat modeling, and whatnot. So we're going to be running them this year live and online because of the same reason we're doing this conference online, the corona. But just take a look at our website and see if there's something for you there. Okay, enough for the plugs and about me. Let's go down to content. What am I going to be talking about today? First of all, I'm going to be talking about an introduction to IoT, what it is, a little bit of the architecture. Then I'm going to go into IoT security, what we see that the current status is, and talking about the attack surface. Then we're going to quick jump into the OWASP IoT Top 10. I'm going to show you a list, and then I'm going to try to go through a couple of examples of the GPS trackers and smart cities to put this all into practice. So IoT, I think everybody knows what it is. It stands for the Internet of Things, and basically you have objects that are interconnected, let's say networked in some way, and they have interactions with the physical world through sensors and actors. Okay? And some of the devices have both, some of them are specialized in one, and what they do is they tend to collect information from the environment, take a decision, and act on it, right? And they allow to automate things, allow for monitoring, data collection, so we can advance on things. In IoT, we tend to separate the type of IoT based on the use case and the technologies involved. For example, we have a consumer IoT where you would have use cases like your smart watches, fitness, smart home, smart plugs, and whatnot. Automotive is actually a very interesting category because all the cars are getting connected right now. If you take a look at a Tesla car, it's probably your biggest and most expensive IoT device out there. And yeah, automotive technologies are just really interesting per se. Then we have industrial IoT or IIoT, where we're seeing lots of development there, right? For example, in the smart city area where cities are starting to work on smart lighting, parking, waste management. You have your typical operational technologies, industrial control systems, and SCADA, which are just production environments. Maybe you have a smart grid, which has evolved a lot over time. So in times of IoT, there's like many devices getting connected. It doesn't matter what sources you look at. The graph tends to look like this one here. So it tends to go into a geometric curve, and or an exponential curve, and it just keeps on growing. So, and everything's getting online, right? There's so many IoT devices. Even, for example, we found an Alexa-controlled toilet. So you can just rule out, Alexa, flush the toilet. If you want to find things like these, you can just pick up this internet account, this Twitter account, Internet of Shit. It's really fun. It's interesting. If you're bored, you'll find something that will make your day on their feed. So IoT is complex because we're dealing with different layers that have to work all together. On one of the layers, we have the devices, the sensors, and the things, which are actually made of hardware, software, or firmware, which is what it's called when it's the small software that's running on top of these devices, this embedded software. You have communication protocols. Sometimes you have gateways that are translating different technologies or routing messages back and forth. You have your network technologies on which these things are built on, right? Which are actually a lot of them. You have a data collection layer where all information from the sensors and the things is going to be going to be able to take decisions, right? Which are taken in the next layer, right? Where you normally tend to have a visualization layer, something that does the business and your different applications that are working on that. Another way to break this down is based on the technologies they use, right? So you have all your hardware where you have systems on chips, microcontroller units or MCUs, sensors, actors. You're going to have your device firmware, which could be a bare bones firmware, which is only dedicated to use for that device, especially slimmed down, or maybe you have something that's based on Linux that would probably fit into your bigger devices. And then they just have a daemon or a process running in that Linux, embedded Linux. You have all your connectivity where you're going to find things like an IP layer, maybe Wi-Fi, Bluetooth, Zigbee, Z-Wave, custom protocols. You're going to have your mobile applications, which tend to be the trendy and the easiest interfaces for most of these IoT devices. You're going to have web applications, which are going to give you your backends to your web applications, so you can control your devices and maybe have a single pane of glass to see all your dashboards. And you're probably going to have IPAs and backends that are going to be enabling everything to work together. From the security point of view, you actually have to deal with all the complexity of all these different layers, all the interactions, and all the weaknesses present in all of them to actually make a device secure or make an ecosystem secure. And with that, we're going to go jump into IoT security. There's a running joke on the internet, it's been there for a long time, that the S in IoT stands for security. Which normally tends to mean that there's lots of devices out there that are not secure, which we tend to agree that is actually sad but true. Most of the IoT devices we picked up out there have not been secured. One of the main reasons for that is that they have a quick time to market, so pressure to get the devices out of the door very fast, and they're pushing for low costs, right? Especially in the consumer IoT area. And if you're doing things fast and without spending much money, you're not leaving much space for security. Security takes time and it costs money because you need to pay for good professionals to do it and to do a detailed work. Lots of the marketplaces and platforms and ecosystems out there are not secure, in many cases because they don't have security requirements in place, to ask for anybody who's getting into these ecosystems that have to comply with them, or actually, and there's no regulatory compliance in many states yet. So we assume that maybe next year or the year after that, there's going to be more laws requiring IoT devices to be more secure, but we're just not that far there yet. In many cases, platform providers and end users are actually carrying the cost of security, because if a big, let's say a big mobile provider, they have if someone gets hacked on their devices they sell you, they're going to suffer a reputation damage, and since they don't want to do that, they are contracting people like us to actually do the test for them instead of the vendors designing and delivering a secure product. And the end users pay for the attacks with their data, or hopefully only their data and not something physically happening in their homes and their environments. So, current status of IoT summed up. Consumer IoT devices, they tend to be cheap, with a quick time to market, and somewhere along the way they turn into disposable devices. And when you buy them, you have no idea how long you're going to be supported. In the industrial IoT or in enterprise IoT, we're going to see lots of binary and proprietary protocols in place, which actually happens because of how these things have evolved, especially when you talk about old technology or actually operational technologies. where these things were developed, with serial lines that went all the way into there. So the only way to interact with these devices was to get on the shop floor, connect to them, having the right engineering tools to be able to understand what the hell was going on. And now they've just slapped on IP connection into that, and they started integrating it and making it easier, for remote login or people to work from home or whatnot. In most cases, they base their security on false premises, right? For example, they just say, oh, we're just transmitting sensor data. We don't need to secure that. Or maybe we're just using network technology X, which is secure, but they forget to actually use these security features. Or, the biggest lies. If all of our communications happen behind our firewalls, it means we're just secure. Now, we know how that ends up. One of the things we've seen is that we're actually, as an industry, we're recycling the IoT industry, recycling bugs and errors from the past. It's like going back to the 90s, where we had clear text protocols, where we would use Telnet instead of SSH, because SSH didn't exist, where we had big problems with authentication and trust management. Right? For example, we use SSL, but you don't validate your certificates. Or we just have non-mature stacks because, they're just new. And these are things that we should have learned already as an industry, right? As an IT industry, or what about, and people should learn things in universities, and it should be part of our daily lives. So why don't we just make the devices secure by design? Well, this is actually the best way to do it. It's the most effective way if you take it from the design all the way to implementation and make it security part of your life cycle. There are studies that can say you can actually save up to 20 times the investment instead of bolting it on at the end. So if my devices are already out there, you already have a product, I have bad news for you. There's no easy way to just bolt security onto it. In most cases, this will actually take a couple of releases until you get that far where you have a more secure device. And you have this, and there's no silver bullets. So how do we do this? Since the rabbit is already out of the hat. There's one, you could just go ahead and do a risk-based approach and do your full analysis. This will take a little bit of time. Right, and you would go ahead and do a complete security assessment where you define your attack surface. You go ahead and do your threat modeling, maybe do your pen testing, and then you have to fix issues, right? And here's when you're gonna have to, where the OWASP IoT can come in handy, because you can use the OWASP IoT Top 10 to use it as, as input for your threat modeling to see if you're covering those big risks, or it's actually you can use that to help you prioritize, because you want to make sure that you fix the things that you can fix quickly and have the biggest impact. Once you've done that, you can do a little dance. All right, so let's go into a little more details. First of all, with the attack surface, we normally tend to split it into 4 categories, mainly, or 4 buckets, mainly because of the know-how and the experience you need to work with them, right? So anything that has to do with the devices and the hardware goes into one bucket. Normally you have vulnerabilities that are based on the firmware and the software that's running on these devices. Then you have mobile web infrastructure and networking security issues, which would be your classical IT security. And then you're going to have radio communication, because you're using different radio protocols in your devices. So what you want to do is you want to start with your threat analysis. You want to make sure you have a big picture. You create a design diagram where you include all of the components, all the interactions between them. Then you pick up your favorite methodology. For example, you want to use Stride or BSMaaS, and then go through each of the interactions and see if you can spoof them, if you have integrity and whatnot. Then you're going to have to fix these issues, right? And one of the hard things is to define your priorities. A common approach here would be to go for the quick wins first. So let's take, for example, the Jeep hack, right? Happened a couple of years ago. These guys, they prepared to talk for DEF CON, and they hacked the Jeep, and they took it out of the road, turned off the motor, radio, the whole, they did the whole deal remotely, just sitting in their sofas, after, taking apart a couple of cars and trading for this. It was not easy, right? And the quick win is asking for their mobile provider to enable client isolation, right? Which basically cleaned out the attack surface, the remote attack surface, because with that, none of the different cars can be spoken to from other SIM cards. And this was actually the best thing they could have done. They should have done that from the start. And then you can go with a bit high impact issues, for example, taking anything from your OWASP IoT. Another way, which is a shortcut, is that you can just test and review your OWASP IoT top 10. Big disclaimer here, this does not replace your security process. The process I described before is actually the correct way of doing it, but this is a shortcut that will, it's better than, it's better to do this first quickly and then go with the details than not doing anything at all, right? So, I've already named this before, the OWASP IoT project. Basically, the idea of the project is to help manufacturers, developers, and consumers understand the security issues in these things. So, what is our top 10 list? The first of all, weak unguessable password or hard-coded passwords in there. You have insecure network services, insecure ecosystem interfaces. So basically, if someone can hack the web interface or the APIs. This is actually pretty big, and lots of devices forget it. You need a secure mechanism to update the devices that have gone out of your shop floor, right? Using insecure or outdated components, which is actually, hopefully you have a secure update mechanism so you can patch and update the components you have in there. Insufficient privacy protection, not storing data, transferring and storing data in a secure way. Basically, encrypt that in motion and in rest. You don't have lacking a device management. Insecure default settings and lack of physical hardening. So let's go into a couple of use cases to see this in place. So word of caution, these use cases that I'm going to be working with are generic use cases. I'm not going to be talking a specific device. This is actually like a collection of our experience with these types of use cases, okay? So we have a device that has a GPS, it has Wi-Fi, Bluetooth, and GSM, right? So it can track anything anywhere, and it uses GPS for fine grain, and you can use Wi-Fi and Bluetooth for the last mile. If you want to find something in the last 10 feet or 10 meters, the a Bluetooth beacon will actually help you with that, right? And your device is connected via GSM with the cloud. You have a mobile app that talks HTTPS with the REST API, and yeah, your mobile app can talk Wi-Fi and use Wi-Fi and Bluetooth to figure out how this tracker works. So what are the typical things you would find on your mobile app? Yeah, take a look at the OWASP IoT top 10 for mobile, right? You will find lots of mobile apps that do not check their certificates. There's no certificate validation. So anyone can do a man-in-the-middle attack. Or maybe they're not doing certificate pinning. Dictionary attacks on the mobile app that allows you to crack it open. Problems with authentication, business logic. Hard-coded password information. So sometimes you can find the API keys that are hard-coded into the app. And of course, using insecure third-party libraries. And of course, in many mobile applications, you will find lots of trackers. You will find, your typical Crashlytics and stuff like that to figure out, so that the developers know what the errors are coming up. You're going to find tracking for the marketing people. So there tends to be lots of trackers, and they are pushing that information out. Which, for the privacy point of view, this is not good. You have to make sure especially in times of GDPR, you want to make sure that you have that under control. Web portals, they tend to have insecure SSL setup. They have problems with authentication and authorization. So for example, dictionary attacks. Injection flaws are your typical cross-site scripting. Or maybe, and often using insecure and third-party libraries, these tend to be JavaScript. So there's too many people using old versions of jQuery in their devices. Please, please, please use an updated version. So on the cloud side, there's insecure API communications because people assume that nobody's going to try to attack their API. Improper protection of resources. You will have things like, for example, the ability to modify data, right? So for example, you could use if you pick up one device and sniff the communication with the cloud service, you can find a way to change the configuration of a different device. And of course, the typical S3 buckets, or basically you're storing information in the cloud, and they're open for anybody to look at them. Device and firmware. These findings actually are a lot more fun. Maybe they have the smallest impact. The biggest impact are always going to be in your central components. They are going to be in your backends and your mobile apps. Actually, mainly in their backends, because if you do manage to do something there, it will affect all users. But these are the most fun, right? So if you crack open a device and take a look at it, you will find maybe debugging interfaces here. Please do not pay attention to my soldering. That is not my best handiwork. But anyway, you can solder on some cables on this, and then you can connect to these things using maybe, for example, something like a JTAG layer to connect to JTAG or serial connections. If you find chips and flash chips on there, you can actually connect directly to them and dump the contents of these things. Often there's no integrity and signature verification of the firmware. That means I can upload any firmware I want onto the device. Insecure over-the-air update mechanisms, and plain text traffic going out of the device. So, summing this up for consumer IoT, most of them are not secured by design or implementation. They are riddled with OWASP top 10s in the mobile web APIs and IoT. Like I said, the biggest issues are in your backends and your APIs, because it will affect all of the customers and not just one user. Normally, if the device is already out the doors, it takes somewhere between 4 iterations to pass a security test, which in time is somewhere between 6 to 9 months. And if it's a startup, they will be CAS stripped, and this is actually not good for them. We've seen lots of companies go tits up because they were, their plan was to sell this to big companies and they couldn't do it. Okay, let's talk about smart city and irrigation system. So this setup is a little more fun. We have devices that are sensors and actors. In this case, we actually have, so we have something that is a sensor that's checking the moisture of the soil to see if, do the plants need water, yes or no? When it detects that, you have another actor which actually opens up the hose and, waters the plant. They are going to be talking Zigbee because it's lightweight and it's trendy, and it's actually a pretty secure protocol. They have a gateway that allows to extend communication. So this gateway is going to be talking Wi-Fi, or maybe has a LAN cable connected to it from inside the building, and it's taking care of the garden that's outside. In the backend, you're going to have an MQTT queue. You're going to have a REST API for the mobile application. And then you're going to have, maybe you're going to have a direct web interface to control everything and have your analytics. So, if you go through the wireless, things that happens often with Zigbee. Did you enable the encryption? Are you doing key management, or is just one key for all time? MQTT. MQTT is a clear text protocol by design. Actually, it's a binary protocol, but it's not encrypted by design. So you want to make sure you want to run this over SSL, or in SSL, or in VPNs, right? To make sure that you have a secure network communication. The next thing you want to make sure is that you're doing correct authentication and authorization, and you want to make sure that anybody is only allowed to talk to the queue that they need to. For example, you want to make sure that no device can change the configuration of another device, or no device can actually write values for another device. So for example, you want to make sure that nobody comes in, and by faking this sensor, they can make sure that they don't want to make everything water be flowing all the time. So on these devices, you will find, or often you will find that these devices are, maybe they're a Raspberry Pi or something similar, and all their configuration is stored on an SD card, which is actually makes it easier to, upgrade and distribute firmwares, but it means that anybody can go up and pull out that SD card, and if it's not encrypted, they can just go ahead and read the configuration and, for example, extract the credentials of the device. You will often find the serial interfaces. So you just connect the right cables, enter, and have the right speeds, enter, and you have a root shell on these devices. Or maybe they have a debugging interface, so you can go ahead with JTAG and dump the firmware, or see debug exactly what's going on in memory to bypass, for example, authentication. You can go ahead and dump sensitive information from the chips. You have insecure verification or insecure update mechanisms, and then very often you have plain text traffic going out of the device. On the cloud APIs, just like I said before, make sure you take a look at the in communications and things like that. On the mobile apps and the web portals, these are known. So one thing that happens in many cases on these devices is that they're not doing encryption because you want to keep your battery life longer, and anybody can just go ahead and fake any of your devices. So if maybe you don't need encryption, but signing them and make sure that nobody can fake messages is really important for you. So to sum up, in our smart cities, you have a large diversity of devices that may be going from Arduino project with shields on top to complex boards with custom firmware, depending on how mature the company is that's doing these, right? Lots of the time, main issues are insecure messaging queues and APIs, authentication, lack of backend or API security, and no authentication or encryption on their wireless devices. And the main justification here is that we're just transmitting sensor data, right? Which makes it non-accessible. Sensors in a parking garage, if someone fakes them all and tells that the car garage is full and nobody can come in for a couple of days, it's just sensor data, but it will be very expensive. So that's all I have for you for now. I'm going to be on the Slack channel if you have any questions. Here's my contact data, so feel free to reach out, and hope you enjoy the rest of the BSides conference. See you guys around.
So, thanks to Pablo here. Here I am again. Yeah, the chat's actually very interesting, so I can recommend anyone to just join the Slack chat that we have set up. You can find it over 2020bsidesmunich.org or at our YouTube channel as well. I have included the link there. We're actually talking a little bit about hardware and modules, about AES, using of encryption, use of standards there. It's actually pretty interesting. For myself, I also see that the security part, if you're working in security, it is somehow that you start with seeing into the technology, and you see that we are actually not as modern as we think from time to time. And on the other side, when you start with security also, so from my point of view, you want to cry the whole time because you're like, what are they doing? Why are they doing that? Oh no. For me, it changed after working now about 7 years in security. I'm like, lol. This they are doing. What happens if I press that? Okay, that's for me the interesting part. Seeing how technology works, seeing how broken a lot of stuff just is, but also seeing how it changes in the last year and recently, seeing that how it evolves from point of processes as well as from point of technology itself. I hope that it's getting better in the next years, but yeah, we will see. Thanks also here to, again, to our sponsors, community sponsors, to our volunteers, to our speakers, everyone having time today. As a little information between the lines, we are live streaming now for about for about 4 hours now, live for 4 hours, and we have actually about 333 viewers right now. So I'm actually pretty happy about it. Yeah. So to our next speakers, or actually our next points. So we have actually finished now with Pablo Andres how to shield an IoT product from the OWASP IoT Top 10. We will now deep dive into the supply chain attacks, the rise of the third-party proofers with Alat Shapira, with the sixth scene here. As you may have noticed, we have now 5 minutes to the next talk, meaning that we actually did it to actually get back to our schedule. We had a little technical problem ongoing with my OBS viewer here. It actually misbehaved at some point. This happens from time to time. Here also the point, everyone who was also recording already knows that it from time to time is harder than it looks like. In my case, it's actually mostly about the let me say multitasking, because I have to take a look at the chat to take a look how it works with the okay. So yeah, then let us start over with the next scene then. Yeah. Really. I know OBS for a while now, but there are always moments where you're like, oh no, where is the button I'm looking for? So just wanted to add this if you just wondered why I was suddenly away, because I was seeing the YouTube live and it just stopped, and I have seen and figured out that I actually clicked the wrong button and the video froze, and I was like, am I online? And it took me now a few seconds really to find the live button again. So doing from time to time really hardcore technical stuff and then killing yourself with a mouse or a button click, and you're like, what the heck is going on? And here I am again. So now the next talk, as actually said, Ella Shapiro with supply chain attacks, the rise of the third-party poopers. Wish you fun, and see you then at 15:30 latest.
Hi, my name is Elad Shapira, and welcome to my talk, Supply Chain Attacks, the Rise of the Third-Party Poopers. I would like to thank everyone who joined today. It's really a great pleasure for me, and I hope you all will benefit from this one. I would like also to thank the organizers that invited me, Maximilian and the other gang members of BSides in Munich. Whatever you do, or whatever organization you're part of, you can't really defend your company or your customers as well if you're not thinking holistically about supply chain attacks. So that's Panorays. We grew a little bit since that picture was taken. You can spot me holding the Panorays logo at the back. I'm head of research and also the first employee of the company, and involved with the platform since its initial steps. And that means that I saw a lot of suppliers throughout the years. And of course, I still do. In parallel, I'll teach a few academic security-related courses. For example, ethical hacking, mobile security, and web technologies at Afeka Academic College of Engineering. And before joining Panorays, I led the mobile security research at AVG Technologies. I also participate on Capture the Flags competitions on a regular basis, and also help to organize hacking competitions such as the Core Wars 8086, a competition where digital assembly programs fight each other on a digital arena. And on a general note, I love reverse engineering, low level and hardware hacking. So supply chain attacks are becoming increasingly widespread as cyber criminals seek to access sensitive data and systems through less secure third parties. So it's important to note here that in such attacks, the victim is not the ultimate target of the attack, but rather stepping stone to other larger networks or corporations. And in this talk, I will present an overview and also delve into various attacks, patterns, specific cases, lesson learned, challenges, and of course, mitigations. So this is what usually comes to our mind when talking about traditional supply chain. Nowadays, organizations circled by multiple third parties that include broad range of companies we directly work with, such as data management companies, law firms, email providers, web hosting companies, and others. However, third-party cyber risk is not limited to these companies. Any external software or hardware that you use for your business also possesses cyber risks. For example, even the JavaScript that you add to your website for analytics may cause a breach or exposing information about your visitors. And also you need to keep in mind for privacy concerns that may be raised. The important thing to note here that all of these are part of the perimeters of the company. So if something bad happens to one of his vendors, it may affect and cause problems to your organization because it's a part of the perimeter. There are few states that an organization can be. You're once a supplier, once an evaluator or organization that work with suppliers, or usually both. So if we take Panor as an example, we have customers. So Panor acts as their third-party supplier or their third-party vendors. But at the same time, we also have our vendors that we manage. So we are also on both sides. The best way to emphasize this concept is to show this group of skydivers. You can watch them here connected to each other and then they switch places. So it's like interaction between companies exists in real life. With suppliers, everyone is connected to everyone. This is how the ecosystem works. And it's like the butterfly effect where if something bad happens on one side, that will affect others on the other side. So no conference for us at Vegas this year. DEF CON, Black Hat, and BSides, some were postponed, some went virtual. So this slide is probably the nearest you can get to Vegas now. And let's brainstorm. Take a moment to yourself and try to think. What are the critical suppliers of a casino hotel at Vegas? So if we take a hotel casino, let's take example Bellagio. What are its critical suppliers going to be? So one can mention a slot machine manufacturer or company that give security services to the hotel. The other can highlight cleaning services or age agencies. So I hope you recognize the person on the right, and also you can recall which movie the picture was taken. So correct, that's Ocean 11, and this is Mr. Zerga. Who is Mr. Zerga trying to pretend to be? He's pretending to be a high-profile gambler. So do Vegas casinos care about high-profile gamblers? Yeah, I guess they are. Why? Because they spend a lot of money on gambling, and you know how it works. They are so wins. So the hotels at Vegas really want their high-profile gamblers to be happy. So we send them wines and chocolates and other goodies, such as taking them in limousines while we're in town. And so we talked with such organization a few years ago, and we asked their security team a question that we ask every company we have interaction with. Tell us, who are your most critical suppliers? And the answer was quite surprising. Try to guess what the response was. So the most critical suppliers of our organization was the local flowers shop, where there's an Excel file floating around and kept unsecured, holding all the possible details of very high-profile gamblers. So this is Excel that worth probably millions or a lot of money. So this local flower shop sent for the year's presents for birthday and to make them happy. And the responsible for the security team literally told us that he cannot sleep at night, worrying about what's going to happen to this file. You probably understood that I'm a big fan of movies, so I can share that a few of my favorite movies are Princess Bride and the Blues Brothers. So try to identify from which movie the image was taken. So it's a fish named Wanda, and there's a hidden critical supply somewhere in the image. You can now try and spot it. Well, I would like you to spot is a fish rank thermometer. If we're still in the context of Vegas Hotel Casino, why do Vegas casinos need to worry or care about a fish tank thermometer? Any ideas? So some time ago, a casino database was hacked through a smart fish tank thermometer. So do we need to have a risk management plan that will take into account all aquariums found in organization facilities? Well, that is indeed an interesting question. Moving to a different one, take a moment to think why the following building is interesting. Try to figure out what it's used for or which company it belongs to. I can give you a hint, but it's not the American embassy somewhere around the world, and you might notice the sign on the wall named Fazio. So this building belongs to a company named Fazio Mechanical. Rings any bell to someone? Correct. This company is related to the famous Target Bridge. So Target was targeted by a refrigeration, heating, and air conditioning subcontractor. The initial info the initial intrusion into Target systems was tracked back to network credentials that was stolen from a third-party vendor named Fazio. There could be two main vectors or agendas for those bad guys. The ones that hacking all the third parties that we are surrounded. One is to get from the supplier to all of its customers. That's the number one seen on the left. I call it spray and pray. And the other is a more dedicated and targeted attack, as sometimes maybe the target is too hard to attack and its supply chain is weaker. So that's a jackal on the right, the sniper-based attack. So this case is associated with the spray and pray scenario. PN Media is a Vancouver-based firm that manages and hosts online photo services for numerous big names retailers, such as including CVS and Walmart. So the case of PN Media, that as you can see, affected multiple of its customers or partners. This one is more targeted one, where the Chinese were able to steal the F-35 planes from Lockheed Martin using a breach in one of their RSA company products. And on the left, you can see the J-31, that reminds a lot of the F-35 on the right. On this timeline, we can see highlights of notable supply chain attacks. Of course, we're not going to cover all of them and deep dive into each one of them cases, but we're going to mention a few. The attacks mentioned in the timeline can be sorted and associated with a few specific categories. Here we can see name dropping of these categories. From the previous list, most of these attacks are associated with publishing infrastructure, such as Peer Breach, Operation Red, CC Cleaner, Linux Mint, and others. Other common are related to source code repositories and SDKs, all that involve this code. The separation between these categories is important, but it's not the right view or the right take. My personal opinion, that it does not matter if a specific attack is implemented with status quo, or if it's part of what I call attack, where you target a website that for visitors and want to affect them. The relationship matters in this case. I'm referring here to the relationship between the companies and the suppliers, or those that are part of their supply chain. So let's try to be more specific when we're talking about relationships. So few questions. Do these suppliers have web access to organization, or do you visit or have access to their website? For example, an HR related portal where you check the status of your candidates. Do you transfer files between the companies? Is it one way or both ways? Is it an interface that persists or continual? Is it for only a short period of time? What data do they hold or access to? For example, do they hold credentials? Do you give them an email account with your domain name, although they're not officially part of your organization? Is it a cloud service provider, a SaaS-based, AWS bucket that can be exposed to the wild? Is it on-prem? Do we give you a mobile application to use or both? For example, I'm running a recording via Zoom, but also have it installed on a computer, also use the mobile app. So I can be targeted from multiple directions or vectors or places. What kind of supplier is it? Is it a managed service, a partner, integrator, a coding services, or an API company? Is it a company that already acquired or you want to acquire and there's a doing an M&A process? Where do the digital assets of the supply is located? Does it matter? For example, is it based in Europe or in countries that US government do not want you to do business with or do not allow you to do business with? Can you tell the suppliers you shouldn't use a specific piece of software or vendors? What is the power that you have on your suppliers? What are going to be your actions when something bad happens? For example, if a vendor is breached, do you disconnect and never do business with him, or let him recover and continue the relationship? Do the suppliers need to notify you about the breach, and a lot of other questions. Size also is a parameter here. For example, let's say you're 5 people accounting firm. I'm sure that if you ask Amazon, for example, for the security related materials, I mean, besides those are published on the public web, for example, the SOC 2, if you request, I'm not sure we'll be able to get much cooperation, but if Amazon participate in a tender of US government for supplying infrastructure for 10 billion contract, we'll have a feeling that we'll be more cooperative and more willing to share info, for example, over recent penetration test and detailed information. Also, another question that jumps into mind, do you need to care about huge companies such as Microsoft or Google or Amazon or Oracle or Salesforce? So if a huge company such as Microsoft got breached, then it's probably not just your problem, but it's a problem to the whole world because everyone is using them. The small vendors are the ones that you should worry about. So what you see is not a map with the infection of the spread of COVID-19 virus. I would like to highlight here the rise of regulations. It is taking effect, and we can see more and more regulations that are related to data privacy, mainly in Europe. And what we see is this website, in this case, DLA paper, gives an overview on the status of relevant regulations around the world. So there are two that most well known, such as the GDPR and the CCPA. And regarding the fines that you can see on the side, it's constantly increasing and the fines are getting much higher. I mentioned that relationship matters, and I wanted to highlight 2 examples that are related to M&A that can share light on these regulations. So what is the relationship between Marriott and Starwood? So as you can see, Marriott acquired Starwood a few years ago. Starwood was breached, and Marriott got a fine for being responsible, as in GDPR, you're responsible even others did not protected well the data. And the different case now, what is the relationship between Verizon and Yahoo? Well, Verizon Media acquired Yahoo a few years ago, and Yahoo were involved with a security incident. But in this case, Yahoo had to take the costs of the breach out of the M&A deal. So maybe they got a better lawyers, I don't know. So that's the take-home message here, always get better lawyers. We'll now do deep dive into various categories that I mentioned a bit earlier. First one is type of squat. First, what is an NPM? NPM is the world's largest software registry. It's like an open source. Developers use NPM to share and borrow packages. So the attack was executed by the NPM user Hackstack, who authored 40 packages with names similar to common packages. Here you can see the initial thread reporting into Twitter. And here are a few examples of the initial info, like the similar package names are the ones that try to imitate in the attack. So the attacker tried to use human error and common NPM naming conventions to trick users into installing the malicious packages. So it's like social engineering, technical social engineering. So that's a great example of the power of the crowd. People in the same thread started to suggest mitigation to this kind of manipulations. So later the NPM team addressed this type of attack. But we'll know and remember that this is like a never-ending cat and mouse game between the attackers and the defenders, or the people that are trying to defend. Moving into published infrastructure, one case that is associated with this category is a peer breach. So what is peer? Peer is a PHP extension and application repository. So what do we see on the slide? You can see that a post from the peer on the Twitter account regarding the breach. So the server distribution system for the PHP libraries was hacked, and the original PHP peer package manager was replaced with a modified version. So users who have installed the pre-installation files from that server within a window of 6 months could have been infected. So since many web hosting services allow their users to install and run peer, this attack may also have impacted the larger number of websites and their visitors. So first of all, what is so interesting here is this is a snippet of the backdoor code. So it remains a mystery why the attacker used the backdoor written in Perl to infect a piece of software written in PHP. So that backdoor opens a shell and connects to that IP address. So the chances are high that the server in VCIP might be another compromised host. Backdooring SDK, moving to next one, what happened in expensive wall case? So in this case, the malware injected in a free Android app, a wallpaper in this case, that would secretly register victims for paid services. So the malicious code in the app came from compromised software development kit SDK that Android developers used. Notably, expensive wall used the obfuscation methods to hide the malicious code activity that could bypass antivirus protection. So at least between 6 million devices was infected up to the maximum number of 21 million. So the attacker able to compromise the toolchain of developer machines and introduce a backdoor in the resulting apps. As such, developer keys can be assumed to be compromised. API security. I really like the tweet that you can notice on the screen. I've seen it a lot. Companies do not pay attention to API that they're offering or to others, or API used within their perimeter. So it's both cases. So it's like a hidden vector that goes unnoticed. There are many cases published on the wild that involve API insecurity or misconfiguration, and here a few. So what happened in the Facebook case, attackers exploited the vulnerability in the Facebook code that impacted viewers. So what is the viewers feature? Viewers is a feature that lets people see what their own profile looks like to another Facebook user. So unfortunately, the vulnerability resulted in the generation of an access token that had the permission of a Facebook mobile app. So not for the viewer, but for the other Facebook user. So that allowed the attacker to steal the other user Facebook access token, and which could then be used to take over the accounts. And as you can see, it becomes a major issue as OWASP started to publish a dedicated top 10 list that focus only on API security. So here you can notice that there's a trend because somebody did an action and published relevant info for people how to get a better security. So there are plenty of websites that help you to, also as a developer or engineer, to map various APIs around the web, or companies that offer APIs. Source code compromise. So what happened here is that it's alarming that people are using code without not knowing any clue about what this code do. So a developer identified as a right to control. A volunteer requested from the original developer to control and maintain the code repository. So that developer gave it to him. So right now there's a new maintainer that maintains this package. And later, the malicious user updated this model with new dependencies and malicious activity. So here are people trying to figure out what's going on, why the package, the model started to become malicious. So it's very interesting to see this discussion between the people. So what the original developer said that is not was not willing to continue and supported it, so he have no interest, so just gave it to someone to ask it to him. And people saying to him, transfer publishing rights to unknown dude, but keeps the repo under your username, well done, mate. So he gave him to maintain and still kept it at his name, so it seemed like a legit one. And here's another case. This is what I call chaos. There was a developer that developed more than 250 modules on NPM, and some of them were very popular and used by multiple other projects. A company reached out to him, to the developer, and demanded him to rename one of his modules because it was similar to the instant messaging app. So their lawyers convinced and claimed that there's a brand issues with that module, and NPM took it away from him. So he was furious, and decided to unpublish all of his npm managed models. So one of them was LeftPad, that worked with, and LeftPad was like, had 2.5 million downloads a month, and you can notice some of the reactions of the people. So another issue that, important thing that we need to notice here and highlight, that someone malicious is able now to take the names of these available models and publish new malicious one. So it's not just a denial service issue that things broke due a developer, and also another security issue, different one. So we mentioned that the problem and show a few cases. So who's the owner of the process? Who's the owner of the security of these vendors? Right now, there's no standard, and we can see various examples. We saw that, for example, the CISO is responsible, and other companies use their legal team for it. Others use procurement sometimes to handle it. And now we started to see more and more cases where there's a dedicated security teams that are responsible for the security of their third parties. So we need to build a process. We need to define all the stakeholders. And later we need to begin somewhere. So first, you need to have an updated mapping of your supply chains and the vendors. It's not an easy task. I've seen organizations that wanted to initiate the program, but they have no clue what is the updated mapping of the vendors. Sometimes they found out that they have supplier breached just because the developer that uses it got an email with a notification from the breach company. So where do we start? So you can take the data from your ERP or similar system, and something that I found is useful. So you can go to the finance related teams and check which suppliers and vendors are getting paid and follow the money. And this is how you can like move the tree and see what is falling and then follow the tracks. Out of these vendors, you need to find which are the most critical ones. So some vendors will bring papers to the office, and some, if you got hit by ransomware, or in these days COVID-19 virus, will affect you if they're out of business. So you rely heavily on the services and products. So can you tell what are your critical suppliers, and know how many critical suppliers do you have, and why you consider them suppliers criticals? Another question, can you tell the impact if some of these suppliers are breached or their security issues? And you need to also important to remember that, keep in mind that not all vendors can be criticals. You cannot decide that everyone is critical. There's no sense in making that decision. And supply chain is not a one-time or snapshot. We need constantly to monitor our suppliers, because suppliers and companies change over time. They implement and adopt new technologies, and the size of organizations being changed. For example, recruit more people, or maybe in this time, it's very sorry, but they let people go. Maybe one of the security teams people, so they have less manpower dedicated to security. And also I've seen throughout the years that companies or customers that have like 4 or 5 CISOs replaced in 3 years. So is it healthy status for organization? I don't know, because the CISO coming to the organization, he knows how it works and then leave, and there's no continual process. So maybe they want to run away before the company was breached. So if, let's say if only for 1 year, they blame, okay, we're only new to the job, and if quickly running after 1 year, they cannot be hacked, and blame if something bad happened. And you also need to have automation placed because of this content gap. So also we need to mind about the people. People's like also digital assets of a company. So if there's a company that give you external HR services and big consultant to work with you, maybe there's a better chance for these people to have security issues with, for example, insider threat. So everybody knows about Snowden, that leaked information about the sensitive projects from the NSA, but maybe you can recall who that woman is. So the FBI arrested in 2019 Paige Thompson in suspicion of downloading nearly 30 gigabytes of the Capital Credit Card application data from. So that woman is accused for the Capital One breach. So employees and human are key part of the company, and we also need to something to help us to understand what are the risks and what is the security awareness level of the people that work with the vendors what we have some sort of relationship with. And another point to raise, what if it's a backdoor in the firmware? Do we as a small company have control or able to have a say? And do we have a way to mitigate? So if, for example, for small lower fees, I don't know if we're able to decide that we are now going to replace every CPU of all the laptops of the organization. So we need to choose the battles. Some battles are lost. What is the fact? And we need to adhere it. So it's all boils down to threat modeling. We need to solve what probably more easy target to the attackers than, for example, compared to hardware hacking. And I mentioned that I love hardware hacking, but it's not related now. So here are a few resources. I will not mention them just to show because of time limitation, but you can go and check out this website and resources, including our website, and the free tools that you can use, and also cool companies that can help you to mitigate API security or source code related dependencies. Another, before the end, important point to note that we're all trying to do the right thing, but it's not a solo effort. It's a supply chain is a team sport and not an individual sport. We can get much more successful outcomes if an industry we look at all in that way. So we need to share info and cooperate and talk to each other and respect each other. And we need to move like a true partnership between us and the other companies because, as I can say, we are usually both the vendors and also the evaluators that have vendors. So bad things can happen to every company, no matter what is a company that spends a lot of money and effort on security, or if it's a small company that do its best. So be kind to each other. That is also a general thing, not just because of security. And here's a recap of what I mentioned during the talk. So third-party suppliers are part of the perimeters. You can be on a few positions, evaluator, supplier of both. There is a rise of regulation and you need to adhere. You need to worry about the small vendors. Relationship matters, and I try to elaborate a lot of it regarding that point. SASO also plays a part in it, but at the same time battles are lost. You need to pay attention to the human factor, and it's ongoing effort. So you need to some scalable solution that will help you to monitor, because some companies have like hundreds of, tens of thousands of suppliers. And the companies have sometimes a lot of more, like few hundreds of vendors that need to map and out of them to monitor. So a practical plan is to decide who's the owner, have an updated mapping, I mentioned follow money, understand which are the critical and impact the most suppliers, automate and scan, of course, security requirements need to include in every RFP and a contract that you do with the suppliers you have. So now I'm free to questions if you have. And before the end, I would like to thank you and of course, again, the organizers, the co-organizers of BSides Munich and in particular Maximilian that let me be here today and share my presentation with you. So cheers for now.
So actually, thank you too, because it was a very interesting talk, and yeah, honestly, most of the work is not done by myself, but by the team I have worked with. So actually, Jen and Chris. So a big thanks here again to them. Also to the volunteers and the rest of the team from BSides. So actually, for example, Morten and Snia are also have also been very frequently at the meetings we had. We had until today weekly meetings where we had to update each other in an hour call on a few specific days where we were like, okay, so how is the state? And yeah. Besides of that, our next points are, so we have now 15:20, so we have in 10 minutes starting the QNet security, a developer's nightmare from Andreas Falk. So I can actually recommend you, if you have questions, you have now still 10 minutes time to also join the Slack channel over 2020bsidesmunich.org. We hope to see you there. We have a lot of memes going on there too. Yeah, and I have also to agree with the dependencies. We actually had it in our Slack channel that it's most of the time also not seen how much vendors you have in also a little company with only a few people working in. And also, if you do own process or something like your own tool, you also have problems like providing new technologies from time to time because they have gone through maybe a little bit longer process and that takes time from here and there. Also, because I got the information, the Slack channel itself will be open for today and will be closed most likely tomorrow. So you can ask questions, you can reach out at us. You can also write us an email if you want to, if we have closed the channel from tomorrow on. Just as a reminder, today is the 23rd of August, tomorrow is the 24th, so it will be closed on the 24th then. Also, thanks to the Twitter community, I have recently seen a few of the posts there. So thank you very much. Also, again, a big thank you to the sponsors you see here on the picture. So BSides, BSides in Stuttgart, Airbus Cybersecurity, Sios, Siemens, Fujitsu, Google, Huawei, Mugler Labs, ITSEC, Kemet Muller, Maltego, Ensight, Cyrus, and Schutzwerk. I hope that you all enjoy how I have shown your logos here. I actually had a Roth setup here because it's always hard to find the right setup. That no one feels like, oh no, I'm not I cannot be seen like I want to be. I always try that I actually do this, but I guess it's fine. And yeah, you will see at 50:30 the Kubernetes security from Andreas Falk. Until then, I will be away. We have 9 minutes break. See you in the Slack channel. If not, have a nice day also, or see you later, depending on what you want to do. Our talks today go until 5 o'clock in the evening, so actually 1.5 hours roughly about to go. Hello. I'll be back. So, no moment. Have to rearrange myself. So actually, you see, I'm a very technical, a very technical guy. So technical guy. So I actually have used the easiest for me easiest to set up 3D printer because I wanted to 3D print, but not want to struggle around with a lot of setup. So you know this problem with this. I hope it works. If not, I hate it. Yeah, it works. So picture, thanks. We have now the 7th and one of the last talks now with the Kubernetes security. Please join us at Slack with the talk 7K8S. You can see it on the conference room, so we would like to see you there. If not, it's fine too. No worries. Yeah, and then let's start with the number 7.
Welcome to my talk, Kubernetes Security a Developer's Nightmare. My name is Andreas Falk. I'm working for a company called Novatech Consulting, located at Stuttgart, Germany. I'm mainly working as a consultant, developing custom software applications for big enterprise companies, like in the insurance branch or in the automotive branch. I'm also a member of the OWASP community and the OpenID Foundation. So I'm always very keen on application security topics as well, like authentication with OAuth and OpenID Connect, Kubernetes security, and security awareness in general. So the first question that always arises at my talks is what about the slides and where can I find the code? So the good thing here is that you can find all the stuff on my GitHub repository with corresponding practical demos, which unfortunately I cannot show live in my presentation today due to time restrictions. So let's start with the path for secure development on Kubernetes. So we will start at application security. The application security is the basics of all the things. So if you have an insecure application, then putting this application into Kubernetes cluster does not improve anything. So Kubernetes does not make you safer from authentication failures, authorization misses, or having SQL injections. So you have to make sure that your web application is developed in a secure way and is authenticated, authorized in a proper way, prevents SQL injections by using prepared statements, prevents cross-site scripting and cross-site request forgery attacks, and also protects your data by using good cryptographic algorithms. So the 101 on application security is use input validations for all types of inputs you are using and getting inside your system. Use output encoding to prevent all kinds of cross-site scripting. To avoid SQL injections, use your Hibernate framework, Spring Data that is using prepared statements out of the box to avoid that. Enforce authentication, authorization on all endpoints, for example by using Spring Security that secures all that out of the box. Never implement your own cryptographic algorithm or your own session management. Use frameworks like again Spring Security. And also always check your third-party dependencies for vulnerabilities. So even if the bad code does not arise in your own code, it can be brought into your system by just adding some third-party dependency. Then automate all the things by using static and dynamic application security testing as part of your CI/CD pipeline. That's also really important. If your application is secured, then the next step would to put that application inside your Docker container, which brings us to container security. Here I start just with the basics to make sure that everybody is on the same page. What is the difference between a virtual machine and between a container? So basically, a virtual machine has some kind of hypervisor running on physical hardware if you have a type 1 virtual machine monitor. And on top of that hypervisor, you have running your different guest operating systems, so you can run a Linux, a Windows system on that hypervisor. And above that guest operating system, you can just install your guest applications. Almost the same is true for the Type 2 virtual machine monitor, with the difference that here the virtual machine monitor is not running directly on physical hardware. But for both approaches, you have a complete isolation between your different guest operating systems controlled by that hypervisor or virtual machine monitor. So if we now look on containers, the big difference here is that containers really run on the same base Linux host, the same Linux kernel actually. So they share the base Linux kernel, they share the same Linux technology. They are just isolated via what is called Linux namespaces. So as you can see, Docker containers or RKT containers, so you can also use other vendors apart from Docker, are completely based on Linux technology. So that's why it's really crucial for you to also learn Linux basics, to understand all the important mechanisms of containers. So as I have already mentioned, Linux kernel namespaces are used to separate the different containers running on the same Linux host. So you have separate process IDs for each container. You can have separate network stuff on running on your different containers. You have several mount points to file systems, separate user and group IDs, and you can also have control groups for each container. So what is a control group? So a control group basically puts resource limits on your container. So it's a bad thing to exhaust all the host resources by just running one container that consumes all the resources. That would make it impossible to run several containers on the same host system. So that's why you should use control groups to limit your CPU usage, your memory, using devices, processes, and network resources. If you're using Java to develop your application, then you should be aware that you should at least use OpenJDK 8 update 192. This is the first version that is really container aware. Older versions just ignore the resource limit set and will just use the complete CPU's complete memory from your host system. They don't care about setting that resource limits. My recommendation here is also not using Java 8, but also going forward using Java 11. So Java 8 is already quite old, quite outdated, so go forward and just update your applications using Java 11, so then you're safe and you are container aware by default. Next mechanism on Linux, which is really important, are the Linux capabilities. So in ancient times, before having Linux capabilities available, you had basically two choices to set up users on your system. Either you have a user that has complete privileges as a sysadmin on the system, or you have the other user that just acts like a standard user without any privileges. But now using Linux capabilities, you can fine-tune all that things and just set the capability capnet admin to a user, for example. So only set the really required privileges for users and running the processes. With Docker, you can also drop all the unnecessary capabilities, like in an example command line on the bottom. Here see a usual use case you will need for running containers like Apache HTTP server or Nginx server, which typically requires to bind to port 80, which is not allowed for standard users to bind to. Only ports above 1024 are allowed usually. So if you want to bind to that port 80, then you need the capability netbind service. So you drop all the capabilities not needed and just add netbind service, that's all. So if you're building container images, usually you write what is called a Docker file. Here you include a base image that you want to use, like Alpine, for example. Then you put in your Docker file additional package installations that you need for your Docker image. And then you also include your application that should run as part of your container image. Then you build your container image, add it to a container registry, just upload it to Docker Hub, for example. And now if you issue the docker run command, then Docker just fetches the container image from the container registry and runs it on your Docker environment. And still remember, Docker containers just share the same Linux host in the same Linux kernel. So by default, if you just run a container out of the box with only standard Dockerfile statements, then it probably will run with a root user with a standard set of capabilities set to that user. But the easy thing to change that behavior is just to add a user to in your Docker file to your container, and then with the user directive, you point your Docker file that it should use that user instead of a root user. And also remember to restrict the capabilities of running that container image. So if you're writing a Docker file, then I already mentioned that usually you include a base image. There are lots of well-known base images available on Docker Hub, like Node.js, Postgres, Nginx. The bad news here is that all these base images have known vulnerabilities inside. It is a bit better if you use the reduced variants of such images, like for Node.js 10, the Slim variant, or even the Alpine variant, that have a drastically reduced amount of vulnerability. But always be aware that these images tend to have vulnerabilities inside. And also always check where you load your base images from. So always load it only from trusted registries, and also only use well-known images, not exotic ones where you don't know if they bring the keylogger and some backdoors by default. Because of that vulnerabilities inside container images, it's always a good idea to image security scanning. A typical image security scanner scans for operating system vulnerabilities, both on base image level and also as part of the packages that you installed in your Docker file. And it also scans all the third-party dependencies on your application for vulnerabilities. And luckily there are free scanner available on the market, open source scanners like Trivi, like Anchor or Claire, can be just easily installed. So Trivi is a really easy to install tool that can be run on the command line and can be easily integrated in all the CI/CD pipelines. So for container security 101, really learn Linux security basics. Then load images from trusted registries only. So restrict to only loading from specific registries is always a good idea. So lots of companies also only run their own private registries and even build their own base images and just load all the images from their private registry. Then always scan images for vulnerabilities, automate that in your CI/CD pipeline. Say no to root. Also run with an additional command line parameter for Docker in that case to prevent privilege escalation. And do not hardcode secrets into your container image. Always mount these secrets as recommended by Docker. Then always limit your resources to not exhaust your host resources. And also use Linux security modules like AppArmor or SE Linux. So if you have made your security precautions on container security level, then we just move on to the Kubernetes part. When moving to Kubernetes, if you already are a bit familiar with Kubernetes, then you probably will know already that Kubernetes can be a really complex beast. So that's why I always recommend not running your Kubernetes cluster on your own. Use a managed one that is provided by big cloud providers like Google Cloud, Microsoft Azure, or Amazon AWS. So if you use that managed one, then you don't have to care that much about the operational security part of Kubernetes. So you still have to deal with the Kubernetes development security part, like you see on the top of that picture here. So you have to be aware that putting your containers, your applications as part of pods on the Kubernetes cluster should be also secure. So what does that mean to you as a developer actually? So you have to take care about things like role-based access control, putting resource limits on your pods, maybe using constructs, what is called pod security context, pod security policies, or open policy agent. So what are these constructs? The first, resource limits, we have already mentioned that on the container security level. So this is the same approach based on containers. So always restrict the CPU usage and also memory usage. And the next thing is Kubernetes already provides mechanisms to also restrict running with root privileges, to also restrict privilege escalation, to restrict writing on the root file system, and also fine-tune the capabilities. So in that case here, as you see, we drop all the capabilities, so we don't need any special capabilities in that case. So the bad thing about container security context is that you have to specify this security context for each and every pod deployment YAML you want to deploy to your Kubernetes cluster. So it's very easy for developers to forget to put in the security context to each and every deployment YAML. So that's why there's another concept called a pod security policy, which is still in beta. So here the idea is not to put it in every pod deployment YAML, but just to install that pod security policy central on the complete cluster. so that it can be used for all the pods. So the bit more complicated thing in that case is that it's a bit more effort to configure pod security policies, as you also will have to use the role-based access control mechanism. So that's why here is the basics of the role-based access control of Kubernetes. On the right-hand side, you always have a subject, which can be a user or a group. So basically, all developers, administrators are users and can also be part of groups. A service account is always bound to some Kubernetes resource, like for example a pod. So these subjects are now bound to roles or cluster roles by using role bindings. And a role or a cluster role then again points to a target resource or target resources. So basically a resource is anything that can run on a Kubernetes cluster. It can be a pod, it can be a service, and also a pod security policy. But this is a typical configuration used for pod security policies. You have a subject, in that case a service account, that you have to specify as part of the deployment YAML in your pod. That subject then points via role binding to a role, and that role then points to your target resource, which in that case is a pod security policy, and in that way you bind your pod to use that specific pod security policy and restrict it from running as root and all that stuff. Another approach to restrict your pods from doing bad things maybe is the open policy agent. Together with a Kubernetes gatekeeper, this agent takes care of restricting behaviors on your Kubernetes cluster. So it installs an admission controller on your Kubernetes cluster, and now if your developer tries to deploy a pod that contradicts some rules that are defined by the open policy agent, then the deployment is denied by the admission control. So you can really fine-tune here all the rules that are enforced for all the pods running on your Kubernetes cluster. So for Kubernetes Security 101, just follow the container security basics as I've shown, learn some Linux basics. Then always use a managed Kubernetes cluster. It's really hard to run your own Kubernetes cluster, especially if you want to be up to date with your Kubernetes cluster, avoiding all that vulnerabilities happening there from time to time. Then also enable audit logs so that you know what your developers, what your administrators are doing on that Kubernetes cluster, or even be aware of some attacker doing bad things on your cluster. Always enforce authentication on Kubernetes. You can also use mechanisms like OAuth OpenID Connect for authentication there, and enable role-based access control. So it's a bad idea for giving all developers cluster-wide admin access to your Kubernetes cluster. Then use pod security policies or the open policy agent with the gatekeeper to restrict behaviors on Kubernetes. And if you're using Helm, then it's a good time to upgrade to Helm version 3. So Helm version 2 had a component called Tiller, and Tiller basically also played root inside your Kubernetes cluster. So version 3 removed Tiller, so it's a good thing as well to upgrade to the latest version. And one really important point is always monitor your Kubernetes cluster. So if an attacker managed to access your cluster and put Bitcoin miner inside your Kubernetes cluster, at least you recognize that with monitoring it. The last part would be about Kubernetes secrets in Kubernetes. So secrets are spread everywhere inside your world. So it's spread into your applications, in properties, it's spread into your Git repositories in clear text. It's spread what is called Kubernetes secrets that are stored in the etcd database. The bad thing here is that all Kubernetes secrets are stored by default only as base64 encoded values, so not encrypted. So it's a good idea to always combine Kubernetes with what is called a key management system, which is luckily also provided by the big cloud providers. So you can easily connect Kubernetes with key management system that handles all the encryption and decryption stuff. And as well, it's a good idea to also combine that KMS systems with your Git repositories to avoid storing your secrets in clear text. So always encrypt secret data at rest and in transit. So be aware that in etcd in Kubernetes secrets are only base64 encoded by default. Always also restrict interactions with the secrets API using role-based access control, and then also mount secrets into your pod instead of using environment mapping to do that. So environment mapping always has the risk of leaking into logs, for example. That brings us to the final summary of the talk. So Kubernetes is a really complex thing, so always check alternatives. So really check if you really need Kubernetes. So if you only have a simple application, then maybe a better approach would be just to put it into a virtual machine on Amazon AWS, for example. Or check other alternatives like HashiCorp Nomad. That is also much more easier to administer than Kubernetes. Also follow Application Security 101. Make sure that your application is secure, preventing SQL injection, cross-site scripting, all the bad things happening that are stated on the OWASP top 10 list. Then also follow Container and Kubernetes Security 101, as I have described in the last 30 minutes. So ensure your secrets are encrypted in Kubernetes. That's also very important. And also never store secrets in source control, like your Git or Subversion control. And then the last point, check out the demos that are available in the GitHub repository. You find practical demos for all parts that I have described as part of the slides. Unfortunately only in theory, so the practical part can be found in the GitHub repository. So I invite you all to just check them out, try out, and see how that behaves in practical. So that was all what I had to tell as part of my talk for today. So I'm happy to answer your questions, and thank you very much. Welcome to my talk.
So, thanks actually to this wonderful talk about Kubernetes security from Andreas Falk. Yeah, I'm actually very happy that most of our talkers and presenters had the possibility to not only send us their presentations and pre-recordings. I'm also very happy about that it worked out that well. So it's actually everything what I hoped for when the people started to do their setups. So we have now a 15 minutes break until 16:15 or 4 o'clock and 15 minutes of the evening, and then we start with our last talk from the art of bypassing endpoint protections for red teaming engagements. This is our last talk in also two different views, because it was also the last talk provided, which I'm very happy about, because we can have a very good insight, I guess, about bypassing endpoint protections. So besides of that, you would wonder how much you can, how much secret and API keys you can still find in some repositories if you just look for that. I'm always a little bit shocked, but I'm actually, for myself, not the biggest fan of Kubernetes, but I know that it makes in specific cases also bigger sense than in the cases I'm using it actually. And the only thing what I can recommend at all is also monitoring. Monitoring is one of the finest things I have found existing on my complete security, IT security career, because you get also a lot of insights, not only from security perspective, but also from the application perspective at all. There are actually a few setups already existing, and yeah. Besides of that, we have also in our announcements in the Slack channel also opened a little bit of a feedback, a survey. We will happy if you attend the survey, because we need a little bit of a feedback. As you maybe found out already, is that this complete BSides Munich as a service was a more or less spontaneously elevated idea. From my point of view, it is also needed to know how you guys, girls and other people found that it works out. We had created it very short term. We had to take a look at this and that. We had a lot of talks about, okay, can we do it at all? Because we needed a while to find also our talkers and presentations, because we had to plan with it, and yeah, it worked out from my point of view very well so far. You may have noticed also that I am also getting tired meanwhile. So yeah, let us make a break here. Also, thanks again to the people helping sponsoring the complete setup and the complete conference at all. Big thanks also to our community in the Slack channel. It's actually very interesting to see what's going on there. We have a lot of memes there, so just come by. I'm actually like very much the Star Trek memes recently, so I'm getting a little bit of Star Trek nerd too. Yeah, so if you see somewhere a Picard or a 7 of 9 meme, you know who is it from. Then see you in a few minutes then with the next talk.
Welcome to BSides Munich 2020 in our talk for the art of bypassing endpoint protection. In this talk, we're going to be basically talking about a lot of stuff about evading, the antivirus evasion techniques, PowerShell, let's say the different evasion techniques or different OS with our beloved one, Windows, of course. So a bit of disclaimer before really starting. We're going to be showing you different techniques, and that involves a bit of vendors. So our purpose, right, is only for research, without any offense or violation to these vendors. Just part of from our research. So who we are? My name is Jamil Napo, and I'm principal offensive security consultant in Capgemini. Basically, I have around a decade with the breaking things legally, and yeah, I have also my colleague Islam right here. I'm gonna be doing the deal in this talk. So, giving you the floor.
Hi everyone, my name is Islam Rida, and I'm an offensive security consultant at Capgemini. I will be talking today with Jamil. We will try to give you an insight on how to evade antivirus and how to make your red teaming engagement more effective.
Cool. So moving forward, the agenda of this, the upcoming 30-40 minute, gonna be talking basically about the issues of red teaming engagement, why you need it. We're not gonna be telling you roughly what is red teaming. This is more advanced tool. We're gonna be also displaying a bit of evasion techniques, tools, things about the manual development, stuff about Windows API, PowerShell and shellcode, and the cool things in .NET Core and .NET in general. Alright, so in order for us to start, if you're doing, let's say, a red teaming engagement, and let's say you're facing you're doing return movement, you're trying to break into the domain control or whatever. So it's obvious sometimes that you're gonna be facing EDR solutions. And it's not sort of, let's say, OSCP lab or something that are going to be real world. So that means you're going to be facing firewalls, going to be facing AVs, advanced AVs perhaps, that involves more than the, let's say, semantic analysis or signature based detection. So it could be behavior analysis sometimes. That depends really on what you're doing. So let's demonstrate it this way. So when you start, let's say you've got into an endpoint. So the lady right here, you compromised it, with the SMB hash, BSexec or whatever. Now, on the other hand, you would need to gain access to another endpoint in the system that in a direct connection with the domain controller. But right here, you got a bit of wall. You got an ADR on this endpoint. So how you're gonna be bypassing this? And what kind of tools that you're going to be using, mainly how you're going to be bypassing this. This sometimes it may look like simple, but sometimes it could really break your red teaming engagement. So that's why you would really need to be prepared. Now, I'm going to be talking about the evasion tools that a few companies, and I work for small companies, and not all of them really afford to pay Cobalt Strike and cryptos or whatever, because at the end it is not legal. But on the other hand, if you're gonna be doing evasion, if you're gonna be creating new FUDs for detectable payload or whatever, you're gonna be using encoders. So encoders is sort of, it's not cryptos is mainly transferring. Let's say you have an executable, then you get you transfer that into perhaps base 64, and then in the runtime you switch it back or whatever. Now this kind of techniques could work perhaps before 5 years, but in 2020 I'm not sure if still encoders work. We're gonna see this in action. You got packers you could be used sort of packer like QPX, that the most popular one, but also get detected because of its resources and stuff. So yeah, signature based tools like YARO tools, YARO rules can detect this very easily. You're going to be using also binders or cryptors. Now cryptors, if you develop on your own, that means in business you don't have really time. So it's really obvious. You're going to be buying tools and stuff, and on the other hand, it's illegal. So what you're going to be doing, you're going to be perhaps taking the open source one, and here you come into the problem. Right here, you've got Cobalt Strike, you've got VO. It's well known in the community for encrypting, creating battle. I'm telling you, if you're gonna be using it, it's all detected. It's all detected. Metasploit, whatever, Post C2, all of these open sources are detected. The reason being, the AV companies is paying full-time guys in order to research in GitHub and create rules against these guys and place signatures and stuff. So I'm telling you, it's not the right choice. All payloads, of course, get detected, even if you create new IOCs. The IOCs again is really popular. Now, right here, I'm gonna be jumping into when you run a malware, what could be the ways in order to bypass the ADs. It could be using you're gonna be using let's say mutex or persistence. I'm gonna be talking this in the upcoming slide. But just as for now, think about it. You want to run something and then keep it over there and make sure that it's if there's another instance that are running the target system, so you're not getting multiple reverse shot back. Gonna be running in the memory now. The modern AVs are able to detect in the memory unless you encrypt it and stuff, so that you make it difficult for them. Or it could be running executables, and when you run executables, you're gonna be facing the UAC. I'm talking about Windows user access control. There are stuff to bypass it, but sometimes you fail in bypassing these, and then you run in a normal user mode, and the user mode could be let's say not allowing you to do any kind of persistence and stuff. So you need to overcome this. I'm gonna be talking about certain techniques. And process hallowing, if you don't know what's process hallowing, just in simple terms, it is simply injecting sort of payload into a process in order to evade the detection. That could be if you have a process, you simply just inject in that process and continue. But that sometimes fail, and sometimes the behavior analysis tool detect that. DLL injections is really simple. You just put your DLL if you find codes or something or whatever in the target application. But this requires you to know beforehand what kind of applications or stuff that are running on the target host. I'm not going to be diving into delivery techniques now. For the mutex, what are the mutex? What does it stand for? What normally, if you regardless, the program language that you develop in it, it could be Java, it could be C# or whatever. But anyway, if you're gonna be first running your own stuff and care about the persistence, so in this case you would need to generate your own mutex. Now the mutex means like random value, random string. Think about it. When you generate it, you're gonna be basically calling. If you're working in Windows, you're gonna be calling in Windows API, when API create mutex. This basically this function can handle regardless of the language that you create your malware in the mutex creation. Now in this case, you could also check if there are other running instances. That the way you do it using the mutex. It's not about the process name, but some EDR solutions could detect you when you're gonna be getting the MD5 out of that mutex, and basically eliminate your privileges. But this is what the mutex stand for. Normally, I've seen red team and engagement. Not a lot of people really care about persistence or whatever. That's more about remote access trojans or tools that use real world attacks. Now, the fun with the mutex is that you can run a file and, on the other hand, take a mutex value of another application. So that means, let's say you run your application a portable way, you try to write in the registry or some places that your application gonna take a bit of priority and run once, whatever what kind of things that you can access it. That means if the UAC is enabled, so it's kind of difficult. But anyway, it's basically you can also spawn another mutex. So you basically take another application value, the mutex value, and then when the system asks for it, your application runs. So that's different than the DLL hijacking or something. It's, let's say, I call it mutex hijacking. You can find it, more information about it in Microsoft website, the cool website. All right, so in terms of persistence, now the obvious one, you can see it right here. It's the run ones and registry keys. You try first to check. These are the a bit of advancement, or the first check if they can write to the registry, and then on the other hand, if there's exception thrown or whatever, they just forget about it, or sometimes they try to write. In order for them, to keep the persistence of the malware, you would sometimes really care about this in red team engagement. Not, let's say, like the RA, but on the other hand, you would need to care. What if the machine crashes? What if your payload doesn't work? There could be a lot of things involved, and especially if you work in a production environment, so you need to really be careful about running your stuff. If you're going to be working on the registry, you could be working with the servers or whatever. Anyway, so you got user init key, explore startup. You could run on ring 3 mode or whatever that you can inject basically in the registry keys, the MBR record, the COM object hijacking, or perhaps in the system 32 you can place it for the file that get initiated or called, like the app any DLLs. So right now I think my colleague he gonna start with a bit of PowerShelling. So take the floor again, mate.
Alright, so we now are going to talk about PowerShelling. What we usually do is using these commands: download file, download string, but we have been using this for a long time, and it's already getting detected by antivirus. So we try to obfuscate our payload. We try to hide this from the detection of the antivirus using obfuscation, but it's also getting detected. So what's even better than doing obfuscation is not using at all download file or download string. Here is an example of a script without using download file or download script. We are using TCP socket. We start by defining the client, the stream, and buffer, and define our variables. The client stores the IP and the port for the TCP socket. The stream gets the stream from the data that we already entered, and we store our buffer in the buffer variable, and we encode it using ASCII encoding. Here we write to the buffer, and we invoke PowerShell, and we start reading from the buffer and saving it in the variable bytes, and then here we start decoding the buffer and storing the data in the data variable using the get string, and then we go on in this if statement by invoking the command data and outputting in the terminal. So it's a try catch block, and here's just some exceptions. So we go on now to the PowerShell demo. We verify that Kaspersky is running, and we can see it's running and everything is working. We start by scanning the script that we created, and it's not detected. And now we have our command ready to run the script. We run the listener and run it, and here we go. We get a shell back. And who am I to verify it? And it's working. And let's take a log so we know we are not cheating. Okay, now we need to verify that after we got the shell, it's already not detected. And we are going to scan it using 36 different antivirus products. So we upload it to clean scan, and let's see. As we can see, none of the antivirus products till now detected our PowerShell script. Let's wait for Sophos and McAfee, and it's still undetected. So as we can see, with a simple technique, we have bypassed the detection of almost every antivirus, and we got 0 detection rate from 36 antivirus products. Okay, so for you who prefer to work with MeterBreeder, to use it as a payload, we are going to use another technique. We are going to use a MeterBreeder payload and include it in a C container. We are going to use MSF Venom to generate our payload and encode it using Shikata, and then take this shell and include it in our C container and execute it in a clean executable. So how is it done? In the beginning, we will start by creating an executable without our technique and see how will the antivirus deal with that. So we are creating MSF Venom, Windows MeterBreeder reverse TCP, and our local host and our local port using the Shikata encoder. Here we are just creating an executable with an encoded payload, which is the old way to create the payload. And now let's copy it to our victim. Okay, as soon as we copy it, it's detected by the antivirus. And let's verify by scanning it. And it's gone. So the normal encoding technique, it's not working anymore. So what we are going to do is we are going to create another payload in C. We're just changing the extension here. After we generate the payload, note the size. Here it's 557, and let's copy our shellcode. We will use that. Let's create a C++ project. We name it clean. Let's create our main file. We will start by including the necessary libraries, and that is studio.h. That's for standard input and output. And we will include Windows, which is the declaration for Windows APIs. And then we define a constant with a payload array. And then here we add the size that we already noted during creation of the payload. And now we create our main function. Okay, here is our technique. We will create an inject. It's empty for now, and we will create a statement here just to verify when the payload is working. Here we start by virtual allocation, so that we can allocate to inject in memory. So we do mem commit, page execute, read write. Mem copy, and here we copy from the payload into the inject with the size that we declared. And here we get our payload. And do return to close gracefully. Okay, we are done. What we can do now is just adding some dummy files. You can create a resource bitmap and create another item here, call it GUI, and just fill in any comment, just confuse the Yara rules. So getting network information and release and build. Now we have our clean executable. We can copy it, and let's see how the antivirus will deal with that. First, let's set up a listener. We are using Metasploit because we used a meterpreter payload. So exploit multi-handler. We set our payload. So Windows meterpreter reverse TCP. We set our local host. And our local port, and start listening. Okay, we go back, paste it, scan it, and it's not detected. So let's try and run it, and here we go. We get a meterpreter shell, and we are in. Let's verify it. Who am I? And we are in. Okay, now it's time to we have seen some techniques. It's time to talk what is the use of this in a real world scenario.
Well, thanks, Islam. Well, I think the meterpreter is definitely not used in the real world scenario, isn't it? Now, and you know, guys, you've got red team and you got the rat. When you're gonna be doing red team, you're not gonna be really running around, and it becomes really different. But on the other hand, there are some similarities. Now, in this table, if you're doing red team in engagement, you don't really care about resistance. You just care about getting into that lady machine and from that popping that thing and then going into the domain controller perhaps. So it is basically like playing around. Now, in real world, resistance is really crucial, and we touching upon some certain points right here, and also the red teaming is all over when you are you take the domain admin, and in the real world it's never over. You're gonna be updating bootnet and stuff. So the attackers, really the criminals, they really care about maintaining their access, and also if you got, let's say, you're going to be leaving traces, perhaps sometimes for the blue team, sometimes this could be part of the deal, and in the real world they get really avoid detecting. I'm talking about could be research institutions and stuff doing these kind of crimes, especially if they are motivated in political way. So they've got money in terms of investment. Now, in the red teaming, you are not really doing a data breach, don't you? So it's mainly about simulating an attack. For the real world, what are you going to be doing? You're going to be talking to the guys, all right, give me my data back. So it's not really it's not really the case. So if there's a breach, then welcome to the club. But right here, I'm going to be also talking about a bit about Yara rules. So Yara is been used for by a lot of vendors without naming them, but let's say the 90% of the majority of the signature-based detection are really used in Yara. So they kind of embedded Yara into their engines and developing interfaces and stuff. But at the end, you've got the same for signature-based detection. So you basically, let's say you've got certain string. It's the same in Linux when you say string about certain file. It could be ASCII, it could be bytes, it could be hex. So you basically, say about the meta description about that file, the resources, you write a bit of conditions, signature based. Now, on the other hand, bypassing the signature base is not really difficult. It is not really difficult at all. But it just need a bit of time about looking what's in there. So besides Yara rules, you've got the behavior analysis, malware detection. Now, it's still in the learning curve because you've also get a lot of false positives. And I've done some engagement, myself from my experience on endpoints on network that contain 20,000 endpoint, 2,000 endpoint. What I'm telling it's a false positive, so it's a time consuming on the other hand. But without digging into that much detail, the behavior analysis, it could be using machine learning, the data set, training set, feeding it with the data, published IOC, TI part. Sometimes they involve process names, and also an attempts perhaps to gain access to certain certain IPs, blacklisted IP, whitelisted IPs, dynamic code, analysis, static code analysis sometimes, or perhaps if you let's say you're trying to create a process that gonna be, let's say you make it an API call, Windows API call, or Linux or whatever you may use in order to bypass the sandbox. So if there's a call for certain process that gonna bypass the sandbox environment, so that way it could be classified and the behavior analysis as the as a malicious, gonna flag it as a malicious file. You can also when you spawn PowerShell, download string, download these kind of data. So that also the way that you may get detected. But of course there are different techniques to overcome this. Because at the end it's a machine, doesn't have the human intelligence. But with that being said, I'm gonna be jumping into ngRat. So ngRat, this guy, has been used over the past, let's say 6-7 years, for by governments, by intelligence, by nations attacks, and basically started in the Middle East, and then it's spread over the world. So here what I'm calling ngRat vs the world. So it's quite true. And the reason that we choose ngRat in order to run up our POC is because this lady is ngRat is I think famous as a detectable IOC more than Pamela Anderson. So that's the reason that we use it in order to show how in a simple techniques that you can basically clean it from all EDR solutions. So right here, before 6 years or 7 years, there wasn't something called .NET Core. Now, when .NET Core came to the table, it's basically putting the capabilities that Java has on the table in terms of across the platform, and that brings available for the criminals, because the more they can reach systems in an easy way that it could take you a couple of lines in order to modify you pay a lot shellcode by whatever you may walk in with. In this case, you can embed it in .NET Core. Now the cool thing about .NET Core, you don't really need dependencies. You can include all the dependencies in perhaps one file, then run it in Linux, Windows, Mac, or whatever, based on Mono. So in this case, that's really cool. But there's a disadvantages when the malware developers, FUD there, make the executable fault detectable is basically the size, because when you include a lot of stuff, so that way they're gonna be a lot of things. But right here we make it really simple, planet simple. Gonna be starting with the demo for NG-RA. We're gonna see it both ways. So let's get dirty. All right. So this is the lady. I'm starting it. Listening to normal port. It's installed. This is basically the server. So I'm building into my local host, binding that same port, and adding BSides Munich as the victim name. Without including any process protection or whatever. We can do that ourselves, but just care about creating the client. So I have already a client, and then replacing it with a new created file right here, and then we got it. Now what we're going to be doing is taking this file. Let's check it out first. Scanning it without any kind of certification or encryption or whatever. So we're using right here 31 scanning, ADR, AV right here, and probably gonna come across all of them perhaps. So right here you can see it's still uploading, and you got 22 out of 31. Surprisingly, Kaspersky saying undetected, but we're gonna move with that anyway. So yeah, we've got other ladies who are saying it's a clean. No offense, but right here you can see it's all got detected. Roughly we have 26 out of 31. So basically all of them, and there are still ladies doing pending and scanning. So that for obvious reason we just took the executable, and then we just uploaded it out of generating it from NG-RA builder. Now let's check the file size. It's 31 kilobyte, 32 on the disk, and the next step that we're going to be creating all of this C# project console application. Right here, we have, this is the program CS, the starting place for our application. We have basically the main method, and we have a class definition called util. And util we use encrypt me and decrypt me. We're using right here, a bit of threat. If we jump into utils right now, you can see that what I'm doing is basically encrypting the string that I'm getting and the byte. Taking these bytes, creating a key. You can define the key that you want, and the initialization vector, the EV. And I'm using right here the Rundle algorithm, which is really basic, normal cipher CBC mode without padding, for encrypting and returning this as a byte array. And the decryption is done the same basically, but the one thing that is different, we just transform it. So basically we're encrypting with the key, and then we're decrypting with the key. And right here we're just calling the output, the file that we generated from NG-RA already. We outputting it into sr.txt. It doesn't matter the extension right here. A bit of threat, and then we're using system.reflection.assembly.log. I think I can write a book about this too, but we're gonna be moving forward. So it's basically just loading, the application, the changing its entry point while the main application already starts. So all right, right here you can see that the folder is empty. And we right now, what we're going to be doing is basically just copying this into our main workstation directory, for obvious reason, because I don't want to define the path, so it's easier right here. So reading from the client, which is the server that we generated using NG-RA, output into sr.txt. You can't commit this line or whatever. Yeah, I'm gonna be running in this demo. I'm just putting a thread just to make sure that everything works. Right here, I'm doing right now a build. So please build a project for me so that the output gonna be nice.exe, as you can see right here in the output. Now, if we go into the project directory, we're gonna find in the bin directory and debug that our file. But you see, the txt is not created that for obvious reasons, because we need the compile time right here. So we're gonna be now starting the application. It's gonna read the bytes from the generated Trojan, encrypt it, decrypt it, load it into the main application that got started. So sort of like, you know, doing jump. So start the application, encrypt, decrypt, and load the other application into the entry point that we loaded. So it's like really simple techniques. Now it's gonna be a bit slow. You can see right here, you know, run as administrator, even though without UAC, I'm getting the notification, which means this machine got compromised, and we've got the reverse Trojan back. You can see that right here, it's working. It's a bit, I think, slow at the moment because I'm using debugging right now, but you can see the files. Let's see if we're gonna get the processes. Gonna jump into the connections. Alright, so we are getting the connections right here. You can see it's working, even though it's in scan time or runtime. All in all, it's encrypted. Now closing this error is basically because I'm running it in debugging mode. But let's now, we verified it is working. What we're going to be doing at the moment is basically see what kind of endpoints EDR Solutions AV can detect our nice file. So right here, you know, you can see the old one. Let's see the new lady. So browsing it. Right, so let's see. Users, Joe, source, repo, console application 1, bin file, debug. Yeah, that's it. Scanning. Let's see what we're gonna come up with. Alright. So alright, so here we have 31, same as the old one. We got in total 40.5 kilobytes, which is not even close to 1 megabyte, and it's clean from all AVs. 0 and 31. You can see right here, it's really hard for the signature based and also the you know, the behavior analysis tools to detect the encryption, because obviously they don't have the key. Now someone may say that it's really easy because you can decompile the .NET code really easily, but I'm telling you that there are methods that you can basically disallow your code to be decompiled. So with that being said, simple techniques, creating, just to wrap up, creating, you know, taking our output from NGRAR, the most famous one, so it's detected from everything, and then, you know, we get in its byte, we encrypting it using symmetric encryption, run the algorithm, creating, you know, AV, we creating the initialization vector, and the key, we're using the same key to decrypt, and it's all hard coded, even though it's clean. So the conclusions: if an AV detects a signature, that sadly means millions or thousands of people got hacked or compromised. Because the way that the signature-based detection works is basically when people, you know, get hacked. Let's say 100,000. Some one of them smart guy uploaded it to VirusTotal. You know, analysts get it, and then, you know, they start, you know, deploying the update for it. So installing AVs is crucial, of course. But just the fact that if someone got detected, that means millions got hacked. PyPass is signature-based detection, as you've been seeing right here. So we used the PowerShell. We used, you know, we didn't even any kind of investigation on the PowerShell itself. We haven't done anything with that. Just creating it, used socket, and got PyPass. The other thing that you've been seeing, the Meta Project Shell, which is also, you know, detected by a lot of people, and also, you know, PyPass with a simple technique, just creating C file, get that shellcode. And sometimes, you know, maybe other AVs can detect that, but on the other hand, you can just split the shellcode to base 64, then you decode it, and then you can concatenate the string. So you make it really harder for them. So it's not something really difficult. And when it comes, we speak roughly on this in red teaming, and it's really crucial that you know what you're doing. Because sometimes, I've seen some, consultants in different engagements, previous companies that they're using, just downloading rats and downloading, shells and stuff, executing without understanding. So what they're doing. So at the end, what they are ended up with is basically a malware, sub malware running, and instead of securing a new client environment, you basically, you understand what I'm going to be saying. So if you guys, gonna be following us, so you've got Islam right here, my Twitter, and also if you're curious about the material, the script, all the PowerShell shell codes and stuff that we've written during this talk, you can find on bufferoverflow.net/this long later. You can just write buffer overflow and gonna get there. Just to not forget the references. So these are the guys who are using, stuff content from there. And develop our own content. So thank you so much.
So this time I'm actually testing my microphone. So it's a few seconds. Okay, perfect. So we are actually more or less right now through our complete day of cool streams. We have it now. Okay, so it seems like it works now again. We had before the art of bypassing endpoint protections for red teaming engagements a little problem with my microphone. I don't know where it came from because here it works still. I don't know. Maybe it just hang up somewhere. So besides of that, thanks for everyone making this today possible. This was the last talk, the art of bypassing endpoint protections for red teaming engagements. I'm very happy to hear this talk. I also had created or actually helped more in creating detections for such attacks, but it's partly useless. So I thought it's very interesting, and yeah, thanks again. A few points for the conclusion of the day. We had our 8 talks today. We had a lot of sponsors, about 15 sponsors for the community. I will thank here again them for the help. Also, I have to thank the complete team, the community, the sponsors, the volunteers, also especially here Chen and Chris, who are not part of the volunteers but part of BSides. And I hope that we can see each other next year at the BSides Munich in a physical version. Yeah, we have actually a very good landing here from point of time. If you have still questions or want to talk a little bit, the Slack chat will be remaining open until tomorrow. Then we will tear it down. After we have talked to the people who had their presentations today, we will also ask if we are able to create a little playlist for the whole talks again, without me talking in between. And without also restarting something in between. I hope also, or especially after my few technical problems and issues, you have enjoying this very much. We would like to ask you if it's, if possible, to also participate at our, how's it called? Survey? Yeah, survey is the name. To our survey, that we know if we should make this next year also virtual, if it's the case that we cannot make it physical again. Thank you for your attention. Have a nice evening. We say goodbye from BSides and have fun.